Ngitshalile imizi yamanani aphansi.
I grow medicines and cosmetics.
I grow designer dresses.
Ngitshala izakhi ezinempilo.
I grow alternative to plastic and fossil fuels.
I grow sweetener.
Ngitshala upende kanye neglue.
We grow sustainable businesses.
Ngitshalela ukuthuthukisa imiphakathi yasemakhaya. Ngitshale imisebenzi engapheli yemndeni ephilisa imindeni yasemakhaya.
I grow libraries full of books.
Ngitshale utshalo mali eNingizimu Afrika.
I grow kitchen cabinets and recyclable packaging.
Ngitshale izinsiza ezivuselelekayo zemvelo.
That is sustainably managed.
Captures carbon while it is growing.
And stores there until the day we throw it away.
I'm a South African forester.
I am a South African forester.
I'm a South African forester.
I'm a South African forester. We are part of a greener, more sustainable future.
Good morning, everybody, and welcome to the Forest Science Symposium. Thank you for everybody in attendance, but a special thank you to our esteemed group of presenters that will be addressing us today. We look forward to a really exciting and constructive day contributing to our research and development in forestry in South Africa. South Africa's forestry industry is privileged to have such a strong research base. We're also very privileged that our researchers and industry collaborate, coordinate, and work very well together to address all the challenges we face in our sector, but also proactively to address the challenges we will face in future. And I'm sure a number of our presenters today will address some of these. Something we've been lacking in the past few years is a platform where research, industry, government can engage, discuss, and talk about what the challenges are and what we are doing to address this. To this end, Forestry South Africa and the South African Institute of Forestry have joined and partnered to revitalize the Forest Science Symposium, to once again provide this platform. When we started organizing this event early in 2022, there were still a lot of uncertainties, specifically relating to COVID, levels of lockdown, and where we would be today. Because of that, we opted to host a virtual event because we weren't sure of the availability of in-person events and could not afford the risk of investing in an in-person event. Going forward, however, we ensure that we will host the next event will be in person and will also be much more expanded, very similar to the old Forest Science Symposium we all attended in the past. In revitalizing this event, discussions between FSA and SAIF, we opted to go to a different model than previous. Although we will co-host it as the two partners, going forward, this event will be hosted every 2 years. What we will also do is, on a rotational basis, we will partner with some of our research partners going forward. So that will give each of our partners every 2 years an opportunity to promote themselves, promote the institution, as well as offer the opportunity for other research partners to engage with a hosting research institution and to get to know them and the institution a bit better. We believe this platform will definitely benefit the sector and advance our research and development efforts going forward. Before I hand over to Mr. Aidan Trolls, who is facilitating the technical side of things in the background, I'd just like to wish him a very happy birthday. Aidan, sorry to have to work on your birthday today, but thank you very much for your support and efforts. So I'll hand over to you. Thanks, Aidan.
Thank you, Ronald. I was hoping to slide by without that being noticed, but good morning, everyone, and thank you, Ronald. It's good to be with you, yourself and Wayne as hosts for the Forestry Science Symposium. It's a real privilege to be supporting you today. Just one or two Zoom housekeeping parameters for the webinar today. We're all familiar with Zoom. We've been doing this, in and out for the last couple of years. But we've got a great lineup teed up for you today in terms of content and guest speakers and presenters. There are about 100 of us online at the moment, so it's also a good opportunity to welcome you. But we would like to make this interactive as a webinar. And so there really are two main channels that we'd encourage you to use. The first is the Q&A. Some of you have hopped onto the Q&A already. We're going to ask you, though, don't use that as the chat function. We really want to profile the questions directed at the speakers for them to answer. If we don't have time in their slot on the agenda, they will hop on and be typing and interacting with you. So questions for speakers, please use the Q&A. Chat box is open, and I'm going to make sure that everyone can participate on that in a moment. So I'm going to have asked you to introduce yourself. So please, the chat is open and open for all conversation and interaction. We just ask that you don't advertise on the chat box, but keep the interaction high. It's really good for the speakers to see what is happening. We are recording the seminar, and slides will be available, so that will be available once we're done. But yeah, looking forward to the rest of the day spent with you. So Ronald, back over to you. Thank you.
Thank you so much, Aidan. Before I introduce our first speaker, let me first introduce myself. I'm Ronald Heath. I'm the Director for Research and Protection at Forestry South Africa, and we'll be facilitating the first session, followed by Wayne a bit later. So moving on to our first speaker, what's nice about today's event for me is none of the speakers really need introduction. They are all our leading minds in our sector. But it's really a privilege to introduce our first guest speaker, Mr. Arnold Kansler. He is a tree breeding specialist at Mondi, a number of years locally and internationally in tree breeding, and definitely a person to lay the foundation and give us some more insight into tree breeding. Thank you, Arnold.
Good morning, everyone. I just want to check that we all can see.
Yep, all good, Arnold.
Yep, all right. All right, well, let me go straight on with my talk. What I'm going to do is obviously talk a little bit about tree breeding, and I'll go straight into it. I would like to, oops. I'm going to be talking about a number of aspects, and they are out there for you to see there. And I'll launch straight away into the first one, and that is talking a little bit about people. So breeders. As we're talking here about tree breeding, so I wanted to just talk a little bit about breeders, and I wanted to talk a little bit about people and the impact that people have on our, or have had and will continue to have on our particular aspect. First of all, just a short slide, and I'm going to really do this in just 2 slides, just to let you have a look at some of our breeders and personalities that have had such a profound influence on South African breeding in the past. I think we can be very proud of our breeding, and you'll see through my talk, I'm going to really be looking at that. If you have a look at some of these people here, they really have had a very profound influence on that. So that's the background. Those are the people that have grounded our breeding. But let's have a look at who we have now. today. These are our current breeders, and I think, to me, three things stand out here. First of all, it's a very nice representative sample of South Africa as we know it today, and that's great. The second thing I'd like to point out is that it is actually quite a young group of people. And if you look at the smiles, generally, I hope a very enthusiastic group of people. And then thirdly, I would like to just point out that we have, for the first time, now got 3 molecular breeders. And I think that speaks to the fact that the industry understands the importance of that going forward, the whole molecular genetics. And I think Dr. Marburg will be talking a lot more about that. So I won't, but I wanted to just mention that and emphasize that we see that as the future of breeding going forward. And I think that is nicely illustrated by that. We actually have 3 molecular breeders going forward. So let's leave that for the moment. So that's the people and an introduction. What I'd like to talk again, just in 2 slides, is the process of breeding. And I want to introduce this first slide. Just I know there's some of you who maybe are not breeders, just to understand that there is actually 4 layers of diversity within breeding. First of all, it's the species. And if we look at our own industry, we have really looked at the species and tested a bunch of species and selected those that have done well for us. Then what we go down 1 layer and we say, well, look, we're interested in these species. Let's go and see if we can find a more diverse set of material from that species. So we're talking about provenance or populations, and we've made selections in that going forward. And then within those very best provenances or populations, we've selected the families. And then finally, right at the bottom, down to the individual tree. And then, of course, we go through the cycle of breeding, which I don't really want to dwell in, but I just thought I'd introduce that as a nice way of just showing the huge diversity and what the process has been. And the other part of that is actually, if we have a look at that in terms of the context of, I guess, 120 years of forestry in South Africa. And you can see again, you know, we've started right from 120 years ago, acquiring species, testing, and then selecting those species that have worked for us. And then later, we've actually acquired bigger populations of those species and tested and selected. And then at some stage, with the impact of people like Professor Bruce Sobel and so on, we've actually gone into classical tree breeding. And actually, and we'll talk a little bit more about that. And then in the mid-80s, we looked at starting to make crosses between species and cloning. Molecular genetics from around about 2000, we invested and continue to invest in that heavily. And then finally, the last part of it is where we've actually blurred the boundary between species itself. And we're actually starting to look at 3-way crosses and so on. So we can't say that this is now patula or Eucalyptus grandis and so on. So synthetics. What I want to do now is go on to what I consider the 4 incredible success stories of breeding in this country. And obviously everyone has their own, but I really think these stand out to me, and I'd like to just share those with you. The first one is really that we have tested an incredible number of species, and within that we've actually acquired huge diversity from pines to eucalypts, and of course also a little bit in the acacias. And I think also we should point out that that has been largely in partnership with groups like with groups like CAMCOR. And so that is really, to me, a huge strength, especially when we look at the diversity of our sites and so on in South Africa. So that's one. The second one, I think, is we've made big progress in actually breeding with some of these pure species, and we've made good gains. And I've put in the word domestication at the top. And I've put that in a little bit reluctantly because I feel that, you know, we're still really dabbling with wild populations. But I think the latest evidence we're seeing with grandis and I'm sure Professor Marburg will talk a little bit more about that, is that we are seeing actually that we have made quite an impact in terms of the genetics of our species that we've been breeding with. So let's call it partial domestication, but we have good populations and we've made good gains with those. So that's the second key success story, I think, from breeding. Then the third one is what I've called the South African Fabulous Four. And these are the 4 hybrids that we have, that we've developed in our country. I stand to be corrected, but I think there is no other place in the world, in a region, where anyone else has developed such an array of successful hybrids that are able to be used across the whole, let's say, the whole array of different sites that we have in this country. And I think we can really be justifiably proud of that. So that's the third one. The next one, and the last one of the 4 that I want to just talk about, is the incredible partnerships. Again, I have had the opportunity of seeing a lot of breeding programs around the world, and I really do believe that we have very close and very effective partnerships with a lot of other organizations within South Africa, and also in terms of CAMCOR, which you'll see on that page. We've developed very, very close partnerships, very, very close opportunities to work together. And I don't think anywhere else in the world are they working in the same way that we are. So those are the 4. I'll come back to those, but what I would like to do as well as I'd like to just talk about what I'll say are the 10 factors that to me correlate very well with breeding excellence. And I'd like to just run through those. I don't want to spend long on each, but I would like to just say that it is an opportunity. What I've done in the past with this is I say to myself, out of 100, if we score a best score of 10 for these 10 factors, we can get a fairly good idea of how we are doing as a breeding organization and where maybe there are some constraints and where we could work on. So let me just quickly run through those. So let's talk about breeding excellence. And I think we can start with, and this is one of my most important things, is that we need to have efficient and effective documentation. We need to be writing reports. We need to be able to say and pass the knowledge that we have gained on to subsequent breeders. So that's very important. The next one is external cooperation. All right, again, I think we're doing pretty well on that generally as breeding organizations in this country, but it is important. We need to recognize that we in ourselves are not an island. We need to be able to talk and share things with external partners and so on. An obvious one, but a very important one, is the capacity for rapid propagation. All right, we not only need to test the material that we are identifying in the breeding program, but we also need to be able to commercialize. So that is a vital ingredient. Then enthusiasm, trained and motivated staff. I think that's very important. And that goes without saying. Long-term vision and goals. Obviously, tree breeding is a long-term game, and I've seen so many times where managers have taken a stance, or the company's going through rough times and so on, and we change our vision and our long-term. I'm not saying we mustn't critically look at it and reappraise it every now and then, but we do need a long-term vision in breeding. And then, of course, long-term support from our management, very, very important. If you're trying to switch a breeding program on and off, it just isn't going to work. Another obvious one is we need to have the expertise to make crosses. We need to be recombination is the name of the game for breeders, whether that's control crosses or whether that's creating environment where we allow some sort of open pollinated opportunity. We need to also embrace new technology. I think we're doing that pretty well as an industry. We're looking at molecular genetics. We're looking at satellites as an opportunity. We're looking at NIR, et cetera, et cetera. I talk about critical mass, and what I'm saying here is that we need to understand that as breeders within our organization, we need to also have other skills and other ways of looking at things. And if the breeding organization is a small organization, that's fine. You then might have to look at trying to have external people that you can also talk to and bounce ideas off and so on. And then last but not least, and I'm talking here about employee continuity, but specifically breeders, I think it's vital that we work hard at retaining our breeders. It is again a long-term game, and if you do not have that continuity and the breeders who stick with the program, it has a massive impact on the breeding program. All right, so that's my 10 elements of excellence in the tree breeding program. Let me now go back to utilizing the Fab 4, and I want to spend a bit of time on that. One word, and I'm purposefully not leaving out the issues around sustainability, global warming, pests and diseases and so on. I think we know those, and I didn't want to dwell on those, but the one that I did want to bring up is competitiveness. Whether you're an organization or a company which is exporting, or whether you're actually supplying the local market, you are going to need to be competitive. And I'll ask myself the question, well, how can research and more specifically breeding or forest improvement help in this aspect? And I've gone through some of these. Obviously, in forestry, we have a very good research technical support. Ronald has alluded to that as well. We have strong partnerships. I've talked about that. We have large diversity in species and hybrids, and we have 4 excellent hybrid products. Can we leverage these strengths better? How can tree breeding contribute to making our industry more competitive? And I think we're not talking here, we do sometimes tend to think of breeding as a long-term game, and it is, but we as breeders have to be constantly thinking, how can I help my organization and my forest industry now or as soon as possible? I'll put this slide up because it's a slide I have shared with the industry before, and it really, what I'm trying to show here, what I was trying to show here, is that there is a process, and that the industry and forestry is moving towards pure species through to hybrids and through to clones. And this picture is actually or could be just as much, or is just as applicable to pines. So whether you're talking about eucalypts and the Grandis nitens, Grandis europhylla hybrids, or you're talking about the pines and talking about Ediota caribea and Patula tech, it is a process, and we're moving towards hybrids and clone stroke family. I just want to take a step back and just tell you a little bit about an example of how they've done a really good job. And this is Dr. Claudia Balocchi in Chile, Araco. And what they've done in that organization is they've actually combined globulus, which has excellent wood properties, but pretty average growth and cold tolerance, and nitens, which in their country has excellent growth and excellent cold tolerance, and combine those. And what's more, they're actually both poor rooters. So, if you look at that, in the face of that, you think, sure, you're dead in the water if you're trying to develop a set of clones or a hybrid from this. But their strategy was that they really tested thousands of F1 clones. And then what they did was they selected the clones with the best rooting. So they only accepted clones with 50% or more rooting. And then they've tested those, let's call them better rooting clones, in field. And what they did was they had the criteria that they needed to be good at all of those 3 criteria: excellent wood properties, good growth, and cold tolerance. And I think what I want to emphasize here, it's a numbers game. It's thousands of F1 clones. And the result is, and I talked to him again, we had the opportunity this a few days ago, talking to him, and he says, absolutely, they've developed what they call Gloni, which is a globulus nitens product. And those clones actually have the wood properties of globulus and the growth and cold tolerance of nitens. But because you're looking at more than one trait and you're looking at several traits, you do need to test many, and I want to say thousands of clones. So if we just take that back now, just keep that story or that success story from Chile in our minds, we have the opportunity with 4 excellent hybrids: Heliota Caribbean, Patch Latec in the pines, and the Grandis Europhylla and the Grandis nitens in the eucalypts. And really, they span pretty much a solid portion of South African sites. So why aren't we using those more effectively? And that's a question I'd like to pose. And I'd like to say that I think if we honestly look at ourselves and all of our organizations, have we even tested, for example, 1,000 GM clones? I don't think so. I know it's hard, but we do know we have winners here, and we can do very well with that. So what I'm saying is we should be aggressively planting up areas suitable with the current hybrid material that we have. I think we're not even doing that properly. And I think we should maybe be focusing substantially by increasing the additional clones and families to identify better hybrids that are more suitable to the range of sites that we have. So taking that a bit further, and just maybe unpacking that a little bit more, we have what we call the Fab 4. All right. Their footprint covers a substantial proportion of South African forest land. We should be planting and aggressively developing these Fab 4 now to fully exploit their potential. Don't wait. I think we are not using them at the rate and at the focus that we should have. And I say, how do we do this? Well, I think, and I'm a breeder myself, I'll put my hand up here. Company breeders' primary focus has to be on the rapid delivery of game. That needs to be up. That is why we are paid. That is the reason we're here. And I know this from our own breeding. We are distracted by a huge number of other things, and that's absolutely right. We need to have a long-term vision. We need to understand and look at other options. But a good portion of our work and focus needs to be on delivery.
Arnulf, can you hear us? It seems like we might have lost him, Ronald.
Yes, I know Arnulf has had some challenges this morning with connectivity. Let's just give me a few minutes to see if you can get back. Apologies, everybody. Just give us a few minutes to see if we can get Arnulf back online. Thank you.
Hello.
Arnulf, good to have you back with us.
I apologize. We obviously lost the connection there.
No problem. We just paused for a couple of minutes to give you a chance to reconnect. So maybe you want to bring up your screen share and pick up from where you got to.
All right. I hope I'm in the right place where I got to. Hello.
Yeah, Bruce, we can. Sorry, Arnulf, we can hear you.
All right. Can you see this?
Yep.
Can you see my screen?
All good.
All right. Okay. I think I don't know where exactly you lost me, but I was talking about how we can make it possible that we utilize our Fab4 better. And I was just talking about there's really essentially a few things. We need to work better as organizations together. We need to have a focus in testing what we have, and we have an even greater focus in testing, deploying what we have, and also testing a lot more families and clones from the hybrids. And we need to make that opportunity available to our smaller companies, I believe. So really just, yeah, in conclusion then, the two things that I think I would really like to emphasize is one is the 10 elements that contribute to a good breeding program, and then really to make an impassioned call to everyone in the industry that we should focus on the 4 hybrids, because we have a fantastic set of products there and we should be using those more effectively. Thank you. Hello, are you still with me?
Thank you very much, Arnulf. Really thought-provoking and a critical review, and sharing your years of knowledge. So thank you very much. Arnulf, I see we have 2 questions in the Q&A for you.
All right.
The first from Andrew Morris, asking about if the future of plantation is clonal, how many should be deployed at any time to mitigate risk of climate change and new pests and diseases?
All right, that's a good question, and I think we do have a sense of some of those answers. It really depends on what the size of your area is, how diverse the sites are, and so on and so forth. I think in terms of clones, again, it depends on the region. If we're talking about a relatively small region like Zululand, probably you should be looking at around about 5 to 8 clones at any one stage, and you should be turning those over rapidly. If you're talking about a greater region, obviously you need to look at a lot more clones. So yeah, we actually do have a fairly good sense of what we should be testing, and obviously it is a balance between not deploying too many clones and therefore diluting your gain, and obviously the risk associated with it. In terms of families, in terms of pines, I don't think we're really in a position yet to be able to say, because we're not testing families, but I think it'll probably be a similar sort of scenario as it would to clones.
Thank you, Arnulf. Rob Perry just made a comment fully supporting your statements of the value of human capacity, and not just in breeding, but in our sector as a whole. I think all of us agree that forestry is a career where we really need to keep our experts and our human capacity up to top levels. Then a question from Rob Pellet. Is there a place for E. dunnii, peer species?
Yes, I think there is a place for E. dunnii, and I think it really must come down to, we shouldn't be focused just because it is a hybrid or just because it is a clone to be planting. No. So we need to be critically looking at each of our sites, and if more value can be attained by still retaining a pure species like dunnii, absolutely. So I think particularly now, there will certainly be a place for Dania. But I do believe that if we focus and really put a lot more effort into testing and selecting more clones in those hybrids, I think we will find more and more opportunities to find clones that will be able to beat Dania. So it's really a rational question of what is the best gain on a particular site, and whether you make a choice around Dania or these hybrids.
Thanks, Olive. Based on that, a comment from Giovanni. He says Dania is difficult to beat, but he says the footprint is at the moment quite massive, which is a risk. What's your response to that?
It is a risk, and it certainly worries me, and that's one of the reasons as well, as I think we do need to, yeah, I mean, I think I've already said that. Obviously, we need to critically appraise it on any one site, whether we should be replacing Dania with the clones. But as far as possible and as soon as possible, I think we need to be putting perhaps a lot more effort into trying to find clones and hybrids, or at least clones in this stage, because we've got GNs that will replace or that can do better than Dania. And I'm absolutely convinced we can. You know, if we look at what we've tested in terms of clones, and if we look at what we've seen tested in, for example, in the Chile example, you know, we really, you know, it's a numbers game. And, you know, if you want to try and pack a number of different traits together, you need to test a lot of clones. And I just don't think we in that position yet.
Thanks, Olive. Another question from Christopher Komakech. What will have to be done differently from tree breeding of the 1980s? More diversity of clonal hybrids, maybe?
I think in the long term, yes. But I think my message today is not so much the long term. I think we've got the long term zipped up. I think we you know, there's opportunities to make a whole lot more hybrids. We have the opportunities with working in partnership with FMG. So we're going to be utilizing that technology going forward. What I'm in a little bit of a hurry and a little bit impatient about is the now. Is from 0 to 10. What can we do now as breeders? And I think there we really are stuck with the hybrids we have. Only thing is, we know they're winners. We have some material that we can place out, and I don't think we're placing it out enough. And we know that these hybrids are winners. So if we just test more clones and families, we should be able to deliver now. It's the next 10 years, I think, that to me is what I'm trying to address now. So Chris, yeah, absolutely. Going forward, I think we're in a good position. We have a lot of opportunities with different hybrids and so on, and the technology we have.
Thanks, Arnold. Then a question from Damien Naidu. He says, it feels like the gain we're making with breeding is only allowing us to stand still due to all the other pressures we face as an industry. How do we go about making that step changes with hybrids while mitigating pests and diseases and climate change?
Sure. Big question, Damien. I agree with you. I think one does sometimes feel like one is standing still. And, you know, the whole question of how much gain we can actually make is an open question. Some people say, oh, no, we can make a lot more gain. I'm a little bit more cautious there. But even if we're just standing still, I think we're still doing okay. But I honestly believe that if we utilize, as I say, we utilize these Fab 4 more effectively, and we actually put a lot more energy in actually selecting a bunch of new clones and a bunch of new families, I think we can mitigate risk and make some gain, certainly on the better sides.
Wonderful, thanks, Olive. Then Dave Everard asking a really interesting question. Are you comfortable that we are focusing enough on site sustainability rather than tree breeding, rather than breeding better trees?
I'm not sure that I'm that qualified to answer that question. I think, I think in terms of site sustainability, I think our sites, from what I understand, what the experts are telling us, I think our sites are reasonably resilient. So I think we're okay with it. Perhaps where that will come in is if we do manage to deploy material that gives us X amount more gain, like 10, 20% more gain, then maybe we are, again, we're going to have to relook at that. But I think at the moment, resilience of site, I think we're okay on most sites. And really, this is probably something that maybe one of the next speakers like Dr. Jacob Kraus and that could maybe and may address in more detail. But I think part of the sustainability and part of that resilience is the fact that we have such wonderful material we can put out, and that we have a huge diversity of that material that we have about. I want to say that there is no other place or no other region in the world which has something like the Fab 4. So I think we can be justifiably proud of it, but I think we need to utilize it more.
Thank you, Arnold. And yes, I believe Jacob will definitely delve into the sustainability issues. So looking forward to his talk. But maybe just from our side, we've seen a significant shift in the sector, looking more at site sustainability. A lot of discussions going on. And hopefully we can, through some of the sector innovation funding that we've received, there's a number of site sustainability work that we hope to fund out of that. So thank you for that. Good question, Dave. Are there any more questions for Arnold? Seeing that we don't have a team.
Sorry, Ronald, it's Wayne. Yeah, I'll interrupt you since I'm sort of allowed to interrupt, perhaps. I had a question for Arnold just regarding the use of, that's one thing that we can get trees to survive on the sites. The other thing is the multiple products. How do we deal with multiple products where we're looking for pulp as well as poles, as well as slow splitting, as well as biomass? How do we deal with that using the Fab 4?
Yeah, that's an interesting question, Wayne, and I think that's always the issue around, should we be breeding for specialist products, or should we rather be breeding for good, resilient, healthy trees that retain, let's call it a nice mix of the material? I personally think if we look at the challenges we have, I think we should be breeding for healthy, fast-growing trees rather than maybe specialty products. I think that's what you're alluding to. Is that right, Wayne?
Yeah. No, it is a tricky one. Yeah,
it's a tricky one, and yeah, if I have to say this as an industry, and I'm speaking with a South African forester hat on, but I think that's probably good for all of our companies anyway. It's looking for more fiber at this stage rather than trying to tweak the little bit of extra cellulose or the little bit of extra, craft pulp yield we might get out of it. Not saying that isn't important, but I think probably in the longer term at the moment, it's making sure we have good, healthy, productive trees.
Good.
Thanks, Wayne. Thanks, Arnold. I think clear message. It's a balancing act. Forestry remains one of the most difficult balancing acts, I believe, with the long rotations and the numerous challenges we face. Seeing if we don't have tea time where we all can chat and enjoy each other's company, please keep the Q&A going for our presenters. But on that note, I'll thank you very much for a very insightful presentation, but also addressing the questions and just getting us all thinking a bit. But thank you very much. We truly appreciate presenting today. Thank you.
Thank you.
Moving on to the next presenter, once again a presenter who doesn't need any introduction, Professor Bernard Slippers, Director of the Forestry and Agricultural Biotechnology Institute, as well as more relevant to us, the Tree Protection Cooperative Program. Bernard is also the Director of Innovation Africa at UP, and with also years and years of experience in pest and diseases. Privileged to have you presenting to us today, Bernard, and talk about something that's on everybody's mind, is a national tree health management system. It's something that we're really looking at, and with the recent launch of the Biosecurity Hub, I think we're moving towards that as a collective, with forestry being definitely one of the forerunners. So thank you very much, Bernard.
Ronald, thank you very much for this opportunity to present to you this morning. Let me just double check that you can hear me clearly. You can see my screen.
All good, Bernard, all good.
See a red pointer on the screen. It's a real privilege to talk to you about this, because I think we are moving into a next phase of dealing with pests and diseases in plantation forestry in South Africa, building on many years of exceptional work that has been done by the team here and our collaborators in industry, in the ICFR and other institutions, and placing us in a position now to, with these partners, start thinking about applying a systematic national tree health management system. And what I'll be doing today, because there might also be some of you that perhaps are not as familiar with the subject, is giving some background to why this is so important. Talking about the elements of what such a system might need, and why we need to also be moving towards precision pest management when we think about dealing with pests and diseases, and then looking at how we might be, some examples of how we might be implementing this at a national scale. My slides are not progressing. There we go. So about 33 years ago, the Tree Protection Cooperative Program was launched in South Africa to deal with a pathogen called Chrysopathy canker. Since then, there's been numerous other pathogens that have been introduced that become really significant. Oops, for some reason, my slides are not progressing. There we go. Have become significant pathogens for our plantation forestry across the different species that we plant, including in some cases for our native plants, invasive pests or pathogens that have been introduced from other parts of the world. So that is already a bad and big mix for us to deal with. The unfortunate news is that this is a trend, and not just in South Africa, but in all parts of the world, that we see continue to increase rapidly, starting from around the 1980s or mid-1980s into the 1990s. This is a trend that we see in many other parts of the world as well. The same is true for insect pests. From a few pests, maybe the eucalyptus snout beetle, one of the most serious ones, and one that has had a major impact in shaping what the forest industry today looks like, introduced back in the 1920s, and then successful biological control introduced for it. But since numerous other pests that have been introduced into the country, some native pests that have adapted to attack our plantation forestry species, and some, again, that have been introduced that are also affecting our native plants and our urban forests. Again here, and this is a picture that Brett Hurley put together, analyzing the number of insect pests that have been introduced outside of Australia. So this is looking at eucalyptus around the world. And again, you see this pattern from about the 1980s into the 1990s, a very sharp increase of the number of the rate of introduction of these insect pests. And we know today that this is largely driven by international trade and the efficiency with which we travel and send material around the world. I think one of the disconcerting things looking at a picture like this is that this coincides since the 1990s with a period in which we have introduced numerous phytosanitary measures internationally to try and curb this rate of spread. And clearly it hasn't succeeded yet in bending that curve. That is not to say that we should stop or reduce our efforts in terms of phytosanitary measures. In fact, we should sharpen, and in South Africa, that's an important part of what we need to be doing, is looking at phytosanitary measures and biosecurity to reduce new introductions. But it also sketches a reality for us that we need to prepare to deal with more of these pests and pathogens in coming years. And that, I think, is illustrated also by this picture from a recent paper that a PhD student in the group did, looking at invasive psyllids on eucalyptus. We have 4 of these at this point in South Africa, but there are 14 that have already been introduced into various parts of the world. And one of the patterns that we see with these invasive pests is that once it starts moving, once it's introduced into one part of the world, within a decade, we are expecting to see that in many, if not most, of the eucalyptus planting regions around the world. That's a pattern we've seen with many of them. So a number of other psyllids that we might be expecting in coming years. And if you then go back to Australia, there are, of course, hundreds of psyllids that potentially can still invade. Not all of them are expected to be successful invaders, but certainly a big reservoir of pests and pathogens that's there. What's also concerning, and something I want to stress, that because I will be referring to it later again in the presentation, is that it's not just that these pathogens and pests are being introduced and the numbers are increasing. It's also the complexity of the populations of these pests and pathogens that we deal with. So these little maps here, maps 2 pests and 2 pathogens, and the invasion patterns around the world that we've been able to trace with population genetics. And what you see in virtually all cases is that these pests and pathogens don't arrive once. Once they start moving, they're introduced and reintroduced into areas again and again. And what you end up with is increasingly diverse populations from multiple introductions, sometimes populations that have never been together before starts to interbreed and create diversity that hasn't existed ever before. And with that, there's an expected increase in fitness in these populations, an increased ability to adapt and overcome maybe even climatic barriers that particular populations used to have, or resistance that might be in our tree population. So that picture too is one that we need to keep in mind. And of course, very prominent in all of our minds is the impact that climate change is having on our plant systems in a very broad sense, but very definitely also changing patterns in terms of our pests and pathogens, their life cycles that are changing, the impacts on our forests. Last night I had the opportunity to sit with Professor Diana Six from the USA, and she's describing a new bark beetle that they're studying in the US, one that's been there forever. It's a native bark beetle, but all of a sudden is starting to create the kind of damage that you're seeing in the background here that it's never done before, with 70% of some pine species being affected, whereas previously there was never this kind of outbreak. So another complexity that we add into this mix. So that might be a bit of a doom and gloom picture that one sketches of just these massive numbers of pests and pathogens moving around the world, the complexity that's there. You throw in climate and environmental variables. You know, how does one actually deal with that? And I want to move into the next part of my talk by referring to this TED Talk from Bill Gates, referring to the pandemic. And famously, I think in 2015, he gave a talk to say, well, if anything is going to disrupt the world economy, it's going to be a virus. And a number of years later, of course, this happened. So his more recent talk is saying, how do we prevent the next one? And he's referring here to this very fancy technology of a water bucket that the Emperor Augustus introduced for helping to fight fires. So he's starting to preempt what might be happening, introducing a very rudimentary technology here. But importantly, the statement that he understood that alone, you can't protect yourself against a threat like a fire in a city, and you need a community to help. And if we now look at where we are now, he makes the point of, you know, fire prevention is not something that we really think about. It's pervasive. When a building is built, you know, there are regulations in place. We all, if an alarm goes off, would know what to do. It's not something we that is foreign to us anymore. And he's calling for, on a global stage, the creation of permanent teams that can be looking out for potential threats and that are ready to respond when these threats come, because they will come. It is predictable that they will come. And the same, I would argue, is true, of course, for pests and pathogens and plantations, and in particular in our plantations, given how large that threat is. But I would argue that fortunately in South Africa, we have all the elements in place. We have these teams, what he's calling there a germ team. We have a South African germ team in place for pests and pathogens to deal with future threats. So what are some of these elements that we need as part of this? What are some of the tools in our toolbox? In this paper back in 2015, we look at and analyze this growing threat. And it's very evident that if you're going to do this, you do need to take a global strategy. You can't deal with this as an isolated company or industry, even as an isolated company. And we're very fortunate in South Africa to have incredibly strong linkages around the world that allows us to do this. And I'll illustrate some of the examples. We also have incredibly powerful tools at our disposal today to deal with these pests and pathogens. Using that analogy of the COVID and buckets of water and where we are today, we really have tools today that are much more powerful than even 10 or 20 and definitely 20 years ago to deal with this. And I'll illustrate some of those. And I think the question that within pest management we have to ask ourselves is understanding the complexity that we're dealing with in terms of these pests and pathogens, and understanding at what level our focus needs to be in terms of the precision that we need to apply some of these tools with. We'll hear later from Zander, and you're all familiar with the work of the FMG and the EPI team. And I'm highlighting here an image from a paper that Zanushka Naidu wrote, that we have incredibly powerful breeding tools and now systems genetics tools that are becoming available for us to look at a holistic manner of resistance engineering in our trees. As we do this, we need to keep that complexity in mind, and that's something that I will refer back to. Biological control has grown by leaps and bounds. We're able to understand not only the diversity in our pests and pathogens, but also the diversity in our biological control organisms. We've been able to establish strong international linkages, formal groups such as BICEP, or through the FAO and others, where we've established long-term programs to support global development of biological control for crops such as eucalyptus. We've also established in South Africa very strong systems to do field extension, monitoring and surveillance, diagnostic clinic that has now served this industry for 33 years, and increasingly new technologies such as remote sensing and data science that we can use to do high precision and integrated monitoring and surveillance. And I'll demonstrate some of how we're looking to do that in terms of implementing a national system. And then as we look to the future, incredible new tools that are coming on board. And I'm not going to spend too much time on this today, dealing with this, but gene editing is not only allowing us to change our plants and produce more productive crops, but it's also allowing us to directly target the pests themselves. And I'll show you how an example of how we might be using that. RNAi in terms of pathogen control are all things that we're going to see within the next decade or so as part of our pest management toolbox. So let me give a couple of examples. I don't need to introduce pine pitch canker, Fusarium cicinatum, a well-known pathogen in the country, causing substantial damage in our nurseries and as these plants are planted out in the field. So something that we've learned how to deal with in terms of within our nurseries, but something that we need to continue to keep a close eye on and unlock powerful technologies. And I'm going to, with these examples, just illustrate how we might be using some of this, such as these LAMP PCR, so real-time diagnosis that we can be doing in the field, so allowing us to do surveillance and monitoring of these at a whole different level. As we're using this knowledge now to breed for resistance to something like Fusarium cicinatum, we also need to keep in mind the diversity that exists within this. And we have the tools, of course, to understand that. Here is a study looking at virulence of Fusarium cicinatum against Pinus patula, and you see this incredible variation that there is in terms of virulence of this pathogen, and that we can take down now to understanding the genes that sit behind this virulence. So our ability to understand this variation is increasing substantially. Another very well-known one of the South African landscape is the Cyrex noctilio that's caused hundreds of millions of rands of damage to the pine industry, and one that we've been able to monitor both through baited panel traps, but also field scouting, and monitor it, not only its spread through the country, but also where outbreaks occur, and use that knowledge to feed back into a biological control system that has, in the end, saved the industry now hundreds of millions of rands. Something that we've been able to refine in South Africa, produce a high quality product that is able to keep this pest under control. But here too, it's worth understanding the diversity. And in a recent study that we've done for the Australian Cyrex control program, we've been able to map the diversity of this biocontrol agent, which is a nematode, in their system, demonstrating that there's actually enormous amount of diversity within their system. And this bigger circle here is where the biocontrol agent that's regularly released comes from. But there's quite a lot of diversity in the background, which we've now been able to show has a fitness advantage over these biocontrol strains, which is something that we can help to even improve this already successful biocontrol. This slide just again shows the variation in virulence in this nematode. So understanding this variation and being able to select the best of these products into our system is something that is powerful that we can now use. And what does the future look like? I've referred to gene editing, studying, so we can study the genomes and are studying the genome of this now, understanding the genes that underpin the mating, the sex determination, are able to disrupt those genes, and you're able to develop gene-edited recombinant Cyrex that either produces non-fit offspring or produces offspring that selects for males, which will, of course, also collapse the population. There's a lot of legislation that still needs to come in place for this to be applied, but definitely something that I believe is part of our future. I will rapidly move through this example, just again illustrating why it's so important that we understand diversity and think about precision in terms of managing these. Leptocybe invasa, a gall wasp on eucalyptus leaves. We've shown that there's not one type, but actually two types here in yellow and in blue illustrated, Leptocybe A and B that's been introduced into the country. It's really important to monitor the levels of these. And as we implement a national system, these are things that we need to be able to do on a regular basis. Not only monitoring this particular insect, but actually being able to monitor the different types and all the biocontrol agents and potential other pests that co-occur in this environment. And that's what you see illustrated here, monitoring over time now, not just Leptocybe's presence, but monitoring whether it is type A or type B that you have in an environment and how that is changing. Why is that relevant? Well, we know that there is substantial variation amongst our clones in terms of resistance to Leptocybe, but it's only been tested to Leptocybe A. So if we hybridize these two, which we know is happening, how is that affecting that resistance? And that's something that we're now able to test. My last example is Gonipterus scutellatus, and just illustrating, so a well-known pest that's caused enormous damage to our eucalyptus industry, but illustrating the fact that we do need to understand where our biological control agents come from. Anaphes nitens was selected from an area that is very dissimilar from where we're expecting it to work in the Zululand area, for example. And we've able to go back and recollect these biocontrol agents in Queensland, similar to our Zululand area, reproduce them and release them in our environment. Exciting new developments is that we're also able to bring in, through these international networks, further biocontrol agents such as these parasitic flies. And this is actually an F1 generation now in our biocontrol facility on the way to developing this as biocontrol in South Africa. There's these powerful new technologies of monitoring damage by something like Gonipterus. And Pumlani and Zuza here, and Michelle Schroeder, working with our international collaborators to develop the capacity to do this on large scales. And this we see translating, as is done for crops now across Africa, looking at production and yield on an annual basis. And this is something that we're looking to unlock for pest and disease monitoring in South Africa, these satellite imagery. I'm moving towards the end of wanting to show how we integrate all of these systems. we're collecting all of this monitoring data. There is satellite data, remote sensing data that we're collecting, various different partners that are collecting either through trapping or scouting or other ways. How do we bring all of this information together? We've developed an online platform, a cloud-based platform called the Information Hub that can do just that. And what we're implementing now in terms of a national system, and thankful for Department of Forestry money that is coming on board that will allow this, we are able, and not in the future, but already able to pull together in real time information from our diagnostic clinic, information from our extension teams as they are in the field, research data that people like the ICFR or ourselves are collecting regularly, trapping data that is collected in the field, and data that's collected by our private companies and foresters who are in the field on a daily basis. All of this being collected digitally and coming into a central hub in real time and being integrated in the Information Hub. This information we're now able to integrate with things like weather data, and in future see that we will also be integrating it with remote sensing and image analyzed data. So incredibly powerful tools with which we'd be able to direct decisions and understand changes in these pest and pathogen populations. So Ronald, with that, I'm going to end and to say that I agree with Arnulf that the partnerships is key here, the capacity to use the new technologies that are coming on board and integrating that in a powerful way to keep our trees healthy. Thank you.
Thank you so much, Bernard. Once again, really insightful, thought-provoking, but also just keeping us on our toes with the threats that we are facing and we will, without a doubt, face going forward. So then moving on to the questions, Bernard, firstly from Tembela. With regard to indigenous forests, are pests and diseases a real threat?
Absolutely. I think, you know, the polyphagous shuttle borer is demonstrating that they're rare. I think the diversity within our indigenous forests prevents, you know, any pest and pathogen coming in here and doing large-scale damage. But something like the polyphagous shuttle borer is illustrating that, yeah, there are some real threats that can be introduced and affect our native forests on a broad scale. Yeah.
Thank you, Bernard. Next question from Andrew Morris. Just quickly move up. Do we have an agreed whole sector protocol allowing for a rapid response to a new abiotic risk, providing for both short and longer term interventions to mitigate impact? Kind of what we do when there's a fire.
Andrew, unfortunately, we don't have that in place for as a standardized protocol industry-wide accepted for new pests and pathogens. They are for the ones that we know. There are systems in place with which we can respond, Cyrex being one of them, industry-driven platforms that allow us to gather the data, unpack the data. I think we are, as I said in the beginning, moving into a whole new phase of being able to do that. I'm excited about these integrated systems that we're starting to implement now. That's going to allow us to collect that information much more efficiently and allow us to implement national protocols. In the past, I'm not sure how realistic it was, because whenever something new comes in, you would have to put the systems in place first to be collecting the information upon which you would be acting. And I think we're moving to a phase now where we would have such systems in place as a background, as a backbone, and that would allow us to respond much more timelessly. There's still work ahead. I mean, this is work that's happening now with the Department of Forestry money coming on board. I think we're systematically starting to implement that or thinking about implementing that. So over the next couple of years, that's exactly what we would like to see implemented. Something that you and I have discussed many times, because we have the elements in place. We needed that support to allow us to implement it, and that's what we have now.
Thank you, Bernard. Maybe I can just add to that is the National Forest Pest and Disease Committee, or the Industry Pest and Disease Committee, actually did go through a process which Johan de Graaf was quite instrumental in developing such a protocol, where you start with a survey, you'll first confirm identification, then it's a delineating survey looking at quarantine and then possible eradication, which is just the basic steps for such a protocol. The challenge comes in when you come to eradication, it means removing your crop and felling to waste. And with forestry still struggling to access disaster relief funding from government, that means you'll do that at a total loss to yourself. So that's something that firstly, the disaster relief funding is something we're working very hard as an industry in the forestry sector master plan. It's one of the specific deliverables. And if we can get something like that in place, I think we can move forward with a protocol that's been developed with quite a lot of thought. But yeah, there's definitely some challenges in moving forward on that. Then Andrew's got another question for you, Bernard. What have we learned from experience responding to Cyrex, PCF, leptocybe, and the wattle rust?
That's one it's going to take a long time to answer. I mean, I think partnership is important, industry-wide collaboration, and that's something that we do very well. I also am seeing Yolanda's question in the next question coming of how do we actually implement this, and I think those are the lessons we've learned from something like PCF and Cyrex. Really speak to how we take some of the new technologies and get them implemented on the ground. But you need structures in place for that. You can't, if you're doing that on an ad hoc basis, as things are popping up, it's really difficult for that to filter down to the forester level, and especially throughout the sector. So Ronald, if you don't mind, I can go from there on to what Yolanda is asking. Indeed, Yolanda, I think we're seeing that also as we're, for example, starting to implement digital tools, that there's a barrier to implementing that. We've got to think really hard of how we make this practical on the ground. But again, the partnerships, the structures that needs to be in place, the support that needs to be in place to implement that on a systematic, continuous basis is critical for, I mean, it's not that a new technology comes on board and tomorrow we can apply it. It takes many, many years of systematically implementing that. And that consistency within structures, I think, is a key element.
Thank you very much, Bernard. Then a question from Professor Mary Scholes. She says, thank you for the question. I think she's referring to Yolanda's question. Then she says, should we be doing short-term guesses together with long-term studies? This is what we do, but should we be changing the balance?
Should we be doing short-term guesses together with long-term studies? Yeah, I think the long-term studies are essential. And if you're suggesting we should be doing more long-term studies, which I think is what you're saying, I can't agree more. And I think as part of implementing a national system, I didn't refer to that in the talk. I think we do need to look at where industry is already implementing plots that are monitored on a long term, and building on the back of that, monitoring systems for pests and diseases. Maybe also linking back to part of Yolanda's question of, what do we need to do more? I think the international networks and doing long-term studies within those international platforms is crucial. Thinking about plots as, sentinel plots. What does a sentinel network for eucalyptus and pine look like in the Southern Hemisphere? CAMCOR in partnership between TPCP and CAMCOR, I think there are enormous opportunities to do that kind of sentinel work, long-term studies that are monitoring change. So I think it's in those partnerships where those opportunities lie, and agree with you, Mary, more long-term studies are crucial.
Thank you, Bernard. And now Giovanni, I think, has also just contributed there to say that in operations, we respond with best information available. Don't wait for number 99, that's for sure. Then adjust as we learn more. With the leptocybe stopping planting of grandis before we just saw the damage to it. And also, Giovanni also adds that there's room for both, but we need to be agile and react as soon as possible. Then another question from Christopher. What suggestions do you have that needs to be put in place for phytosanitary regulations to become effective in SA and possibly regionally SADC?
Yeah, I think we have lists of priority threats that we need to be monitoring for, and continuing to push for the implementation of those lists, and making sure that information from that gets to the right place in a timeless manner. I think that that's a big issue at the moment in terms of information flow and the time that it takes to for information to flow. But I think capacity to do that is a big issue, especially if we think at an SADC level, and if we think about governments needing to manage that. And perhaps that's, again, back to a point that I've reiterated a couple of times now of the importance of partnerships, the importance of something like a sentinel type approach. So others planting eucalyptus and pine in Southern Africa and the rest of Africa, partnering with them to have structured monitoring and surveillance systems in place as pre-warning both ways, I think is essential. Sharing things like control mechanisms is in everybody's benefit. So I think those are some of the elements that we need to look at.
Thank you, Bernard. I think just to add, you talk about the collaborations, but industry has been working very hard the past probably 7 years to get closer working relationships with the Department of Agriculture, Rural Development and Land Reform, specifically plant health and inspection services, where we're providing them the information of the risks. Our biggest challenge is, while we're seeing that only about 3% of anything that comes into our country through our borders are being inspected. If we can't address that critical shortage of human capacity and up that 3%, we can have the best phytosanitary regulations in place, but we can't implement it. So it's once again one of those, we need more to help us. Bernard, on that note, thank you very much once again for excellent presentation. Also, once again, thank you for all the questions posed to Bernard and opening some conversation. Please continue to also continue the comments in the chat box. We really appreciate that. On that note, Bernard, thank you so much, and we'll move on to our next presenter. Thank you.
Thank you very much.
Our next presenter, coming all the way from the Cape, Professor Bruce Talbot, also born, bred, and educated in forestry in South Africa at Stellenbosch. But once again, privileged to have gone overseas and bring back the knowledge you gained overseas and bring back to South Africa, strengthening our education program at Stellenbosch. Bruce is at the moment the Associate Professor for Forest Engineering. He's also the Department Head of the Department of Forest and Wood Sciences at Stellenbosch University. Bruce, thank you very much. We look forward to your presentation.
Thank you, Ronald. Good morning, everybody. Let me get this screen shared with you. It's hopefully the correct one. Yes. Okay, great. Yeah, so thanks, Ronald, for that introduction. Bernard, also a very interesting presentation. I think a lot of the people speaking here today are actually talking about precision forestry in many ways, but I've been given the opportunity to actually just focus on that as a topic. So that is what I'm going to do. So precision forestry, of course, is not a very new thing. Pierre Ackerman has been hosting international conferences here since about 2006 in precision forestry. I think it was. So it really encapsulates many different parts of forestry, and we really need to look at coming to some sort of collective understanding really on what that is. And that's what I hope to do just through a few slides here. Then I want to go through some of the work that that our group has been involved in. I know all the companies are doing a lot of precision forestry work themselves. And then I just want to sum up with a couple of observations or ideas on where we kind of headed with all this data that's coming from this precision forestry. So let's just see if this is going to work. Not. Yes. So how is it defined? Now, there are many definitions floating around, and I've just chosen to go with this quite a pragmatic one. And actually, I'm going to use this report quite a lot through my presentation. And this report by Chaudhry and O'Kelly from 2018 from McKinsey Company. And those of you that, yeah, well, I'm not sure if you know of the company, but it's a global consulting company in the forestry sector. So really, what they say is the principle of precision forestry is that it uses modern tools and technology to get as much real information as is possible to improve decision-making process and to ensure current goals of forest management. So that's just actually quite a pragmatic thing, and it really just keeps it more or less open to everything. But we have an objective or a goal of improving forest management. So sorry, I don't know why it doesn't want to change slides here. But I've just stolen quite a few of the illustrations from that report. And in this one, they're just showing what does it actually mean, the transition from conventional forestry systems to precision forestry systems. And there, I think South Africa probably is already much in the precision forestry when this report was written, because it was obviously global and had quite a wide scope from probably Nordic or North American kind of forestry. Well, we should know Andre Wise. I don't know if Andre is with us here today. Andre works for this company today, but wasn't, of course, at that time. So just some examples: natural regeneration of forests with seed trees using the same genetic material, and that goes in the precision context more to selectively bred and clothed seedlings raised in nurseries under tightly controlled conditions. Of course, our plantation forestry, and we're going to hear more about that today from Zander, amongst others, is very advanced, I would say, already into that precision concept. Use of standardized fertilization prescriptions, another example, whereas here you're going across to site-specific fertilization and kind of high-resolution assessment of soil nutrient deficiencies. Manual in-field forest inventory. This is probably something that's changing now quite a lot. So we still do that, of course, but we are moving across to digital forest inventories using UAV data or LiDAR or sort of ground-based scanning with mobile tools. Motor manual harvesting with no data capture. We have in this country about 65% of our 16 million cubes are cut with machine already. But that means that a huge amount of data is being generated, and that is a question of whether we're using that. But we do get information from fully mechanized harvesting that wasn't previously available from the actual harvesting process. And then reacting, of course, to fire. Well, that's just one example. And I think also in the country, very advanced in that with the systems that we have in place, which are actually beyond just satellite and drones. But this is just to give you a little bit of an idea of what the idea is behind precision forestry. I'm going to go through a couple of those topics just quickly. This one you will hear about from Zander, of course, the advanced genetic improvement, gene mapping, and tree breeding to ensure plants have the genetic profiles needed for the end use, also in terms of diseases and things. And automated nurseries. I think our nurseries are quite up to date there, not only fully automated, but also the collection of data is on the condition of the seedlings has a lot of potential in precision forestry. In forest management, site-specific management prescriptions, adapted to the site. You're looking at pest and disease monitoring, as we just heard from Bernard. That's extreme level of precision forestry that they are currently working with. In mechanized silviculture, those of you that heard the webinar a couple of weeks ago from NMU would be up to date with what the latest happenings are on mechanized silviculture. Our own MPAT system in South Africa is probably one of the most advanced, actually, globally in terms of precision location of seedlings. Fire monitoring we've discussed, and water management systems, of course. Okay, I'm not going to be going through this all day. This is the last slide on this one. So in harvesting, well, digital inventory is not exactly harvesting, but this is what we were speaking about, doing the inventory from the ground or from the air with new devices. Mechanized harvesting, obviously, if we manage to get that to be calibrated and to work properly, there's huge potential. There's probably about 20 million trees a year being harvested, if not many more. Yeah, it must be more than that. And that you could get the individual tree data from the harvester on. Now, wood delivery is another thing. I think we have been in the past quite advanced in that area, and at least in the wood logistics optimization. Something that they're naming here is the use of loading cranes that can be operated remotely. That actually is a thing these days. We do have virtual reality cranes. Not that that's precision forestry, but it does relieve the work to some degree. I think something that's more coming about these days is the remote operation of forest machines. So from some distance teleoperation, which is being seen in some countries around the world already. So just to look at the the main sources of the data really, remote and proximal sensing. That can be satellite, UAVs, aircraft, mobile or personal. So that's something that is worn. External open access data, climate data, business conditions, transport rates, the conditions of the highways, whether the traffic's open or closed, or market trends, contractor prices. We have a very broad input, which is what really the definition of big data and going into, or big data is really also a part of precision forestry. But we have mechanical and technical data on productivity rates, technical capabilities, consumption rates, trafficability in the various stands, organizational stuff about the logistics, the sequencing of operations, the management of those. And then finally, at a more sort of an umbrella level, is really getting the information out of all that data, and that is the knowledge generation that comes from more systems at a higher level. So I'm just going to show now a few examples of what we could call precision forestry elements that we work with in the group here, but also just across the industry in South Africa at the moment, just to give you a bit of a feel for what the status of some of this work is. So the first one is really stump detection and measurement. I've just tried to put this up as a concept because my title was really to improve competitivity. And with that, I think we mean improve really value generation from precision forestry. We're not just doing it for the sake of doing it, but how we can actually add the value and how to quantify that value. So what is actually the value of doing something like that? So I'm trying to not put rands and cents down, but just conceptually where that value comes from. So we'd be doing stump detection, and this is some work from our master student, Alan Hubbard, measuring the diameter and the height with UAV data. You can use it to monitor the stump height, that they're not leaving excessive stump heights. Can also be, that information can be used to model CO2 and volumes for biomass. And then, of course, the value adding is one really is maximizing fiber yield by ensuring that the stump is utilized to the greatest possible degree. Another example is using harvesting residues or assessing the residues. The reason you want to do that is because sometimes you want to use those for energy, and this is something that is becoming more and more relevant. Harvesting compliance with specifications, so where we asked to windrow the residues, or what was the requirement on that. And then, of course, also to be able to plan and assess other forms of residue management, whether they're going to be mulching or burning or scattering. So you have some information on that. So the real value added is you have a good estimate of the biomass feedstocks, and then also whether the residue management has been correctly applied. So this is some work from Alberto Udali, who was out here earlier this year. We have a cooperation with them from Italy, and they will be visiting us again in the near future. Seedling detection is something we've all seen a lot of on the social media, at least a lot of very impressive slides going around on LinkedIn. And I know that some of you are involved in that work as well. This is just one example of that from our master student, Jamie Koch here. So obviously the intention is to try to detect seedlings as young as possible. So, and also, of course, of different species, or at least for if you're going for pine or eucalypt, because there are different challenges associated with each. And the idea really is to have a seedling count and to know more about the need for blanking. And that's why it's necessary to get it at an earliest age as possible. But there's also other, of course, advantages to getting a map like this out, because you can see that you have a very sparse or very low survival in some areas. And then there is an opportunity to really look at developing survival models, or looking at what the underlying causes of that could be. And that might be moisture, if you use moisture modeling, or frost modeling, and looking for some sort of correlation between those. One would actually generate value by knowing that it would be maybe pointless to replant that species, or plant seedlings of a certain size or time of year. So something else that we just heard about as well is the pest identification. So weeds and pests, I've just thrown this into the same site. This is really just based also on the seedling detection, but obviously anyone can see here that weeds can easily be identified, or some other vegetation that is not the actual seedling that you're looking for. So this is using machine learning that identifies the seedling, and anything else is not that is not seedling can be monitored and perhaps treated if necessary, and when it exceeds some sort of threshold. And the value adding there is, of course, that you have a very timeous detection. If you have a high temporal frequency in your data, you also have the opportunity to see whether the weeds coincide with moisture models or soil types, and then one can also monitor the treatment effectivity. So if spraying, you can also spray in a very precise way with a drone given this map, and you can also use it to monitor how effective that is over time, which is very difficult to do from the ground. Trafficability assessments, determining roughness of the soil or soil bearing capacity. This is something that is actually done by our bigger growers. This is based on LiDAR, so they have a pretty good idea of the actual accessibility and stand, especially with regards to surface roughness, which is important when you have ground-based harvesting systems, and you are able then to improve your estimates of what the performance of those systems will be on a compartment by compartment basis, which is really a very direct indication of costs or costs saved. On a more, just bring the other map up here. So on a more, if you're looking at soils, something else that can be done in that modeling based on quite precision data is to bring up the moisture models, which do give you an indication of where it's going to be, where the soil will be soft or more susceptible to damage, depending on season, obviously, and on soil type. So these models need to be worked on a little bit to incorporate those factors, but you do get an indication of where to drive or which areas you should avoid. On the harvesting side, so we have forest machine data. I just showed an example of what that data actually looks like when you pull it out of the XML file. It really is very, very detailed. You have the date right down to the second when the tree's being cut, the stem number, single tree processing. It's saying here, it's showing you the position of the harvester itself, the angle, the bearing of the machine, the angle to the crane, and it's estimating the position of the actual tree when at cutting. And it's giving you, of course, the time that it takes to process the tree, as well as the outputs in terms of assortments coming from each log. And that gives us relatively useful data for a number of reasons. One is that you can use it to improve taper models. This is an example of doing exactly that. So these are the actual measurements from the harvester on a single tree, and you can see how they try to fit a curve to that data. Something else is obviously one gets a good map of where the harvester worked through the compartment to see where that the whole area was covered, and of course the development of heat maps, which could be based on volume or certain volume-based, or also product-based, or species, or whatever it is. I'm indicating there. Okay, I can see I'm running really low on time here. So environmental risk, I just wanted to show that's also based on very high resolution DTMs, and the possibility to model surface runoff or surface erosion on sort of a micro catchment basis. So having such high resolution terrain models, you can see that's the size of a vehicle there. The actual catchment area for an amount of sediment that has been captured somewhere can be calculated, and this can be used to develop more accurate models. Okay, something is similar with wheel rutting, really, that you can use to predict wheel rutting, or you can use it to actually using machine learning to find the extent of damage in the compartment. Roads and transport, this is quite interesting because this is really just a smartphone that's taped to the dashboard of a vehicle and running an app. The smartphone has all the inbuilt sensors that you need, GPS, accelerometer, and the rest of the IMU. So that can record the quality of the surface of a road and feed the data back. So you could see that there's a pothole about here. That is the extent of the Z direction that you got from driving there at a certain speed. And when these are running on multiple trucks or vehicles, you obviously are generating a large amount of data on that. Something else is also the geometry of the road. So a combination of curvature and slope was obviously interesting for road, which kind of road vehicles you're going to be using there. And that is taken more from the LiDAR analysis. So the question is really what to do with all that data in a way. We heard that also from Bernard previously, how to bring it all together to make some real kind of contribution. Really what is the sum of the parts? Are we doing some of this just because we can, or are we doing it because it is necessary? And which part contributes really the biggest, makes the biggest contribution to value generation? That's a little bit the question. And just in kind of almost closing is the overall value chain perspective. So going back to that, using the data from all those elements that we just saw, those have to be incorporated into forestry planning models, into support tools so that one can be in the field and get that information that has been captured into e-dashboards so that you can visualize the performance and relate that to the basic information. And then into some advanced analytics. And of course, we were speaking about that the other day, and there are the optimization and econometric methods that would utilize that data and give you insight at a higher degree than one would be able to just with the existing methods. This is my second last slide. I think I'm a little bit over time here. Am I okay there, Ronald? I just want to show quickly just really in a very schematic way that just want to illustrate why it is that we're getting all this data and what are we really doing with it. So if we just look at our inputs that we have in operations, whether we consider these are 2 harvesting operations or silvicultural operations, you have your capital, labor, management effort into that, the skills of the people doing it, the materials that have to go into it, the infrastructure had to be updated or upgraded to handle it. You can see that you have higher inputs and lower outputs, or you have lower inputs and higher outputs. And that's saying something about really the efficiency of the operations. And generally, we're getting quite a relatively wide spread of those with today's methods of collecting data and today's methods of sharing the data with the people actually carrying out that kind of work. So it's just to illustrate that there's an efficiency frontier that kind of exists that describes really the optimal or the best possible outputs you can get from given inputs. And we need to be able to explain the deviation from those. And precision forestry is one thing that would contribute to one element of that at least, and that is just that you didn't know. So now you do know, you do have more information, and that basically increases the efficiency beyond that frontier. So that it should hopefully move us to a new efficiency frontier, which gives a higher rate of output to the same input. If we are not using too much effort in gaining that data, but it needs to be generated more or less automatically and using efficient analysis methods. So beyond the efficiency frontier in itself, the last one is really the new frontier that is going to come about by applying this knowledge from the precision forestry in those systems that I was just speaking about, and hopefully taking us through to the next level. Conclusions: precision forestry data collection techniques continue to develop, but they are beginning to mature. So if we think about LiDAR, drones, RGB, whatever sensors we're doing there, I think there hasn't been a huge development. Of course, the accuracy or the resolutions improve, but that technology is really starting to mature, and now it's more a question of how to interpret that more efficiently and develop what they like to call actionable insights, which is quite a nice term, in a phase of, this is in a phase of rapid development and innovation and improvement. And what's really interesting there is that the openness of the society that's dealing with these things. So we're talking here about things like machine learning, artificial intelligence, machine learning as a part of that. But the openness in sharing that is quite remarkable compared to a lot of other less intelligent data or procedures we've been working with in the past. So there seems to be a huge willingness or an openness to exchange the latest developments on some of these algorithms. And that I think is what really is feeding the process forward. Probably the bottleneck that still remains is the implementation of actionable insights. So once they are developed, how to actually get them out back into the plantation. And the final one there, just saying that that this data that we do generate really needs to be incorporated into the smart optimization or econometric planning modules. So if we're going to really use the potential of that, we need to make sure that we go the whole way and that we're not just collecting data because it looks nice. And there's an example of that. Ronald, sorry, I went a little bit over time, but that's what I have.
Bruce, thank you so much, and no apologies needed. A really exciting talk looking at what is available. We are out of time, but I think the two questions that have been posed are really relevant to your concluding slides. So I would like to, if the audience, I'll just take a few 2 to 3 minutes. So the first question is from Lelo. How far are we from counting seedlings within the nursery, especially eucalyptus?
My answer to that, we actually had a student working on that last year, but it was not so much on the counting and more on looking at the condition of the seedlings. So I think you're counting live seedlings or healthy seedlings out of a tray, I guess, is the question. And that I'm sure that there's some people at Sapien Manu that would love to answer that. I mean, the student that we had that worked on that had some success with it. There are certainly still challenges, but if you think what happens in the flower industry, if the Netherlands and stuff, I think that these problems are being addressed quite quickly. But yes, it's not the easiest thing to do.
Thank you, Bruce. But definitely, as you said, there are things being done. So the question and statement from Giovanni is very relevant to your last two bullets, I think, your conclusion. So Giovanni says, current challenges is operationalization and the use of this tech and associated derived data. He says, we know how to do these things, but all of them actually take more time and resources to generate, serve, and use in modeling than may be expected. Also, contracted operations pose a future obstacle to actually use the data. What are your thoughts, Bruce?
Yeah, well, I didn't write that down, but I think one of the things I was thinking about in preparing for this presentation was that I think for a couple of years from sort of now on, and maybe 2 or 3 years down the line, I think that the industry is going to have to invest quite heavily in the development or making that happen, looking at easier ways of utilizing this big data and making those things happen out in reality. It's not a permanent challenge, it's just a short term, but I think a lot of resources are going to have to be put into that if you're going to get through that, and come out the other side winning, because we can't really just go slowly with this because it's moving so fast. It is a bit of a tsunami of information, and I think that we have to really invest in the capacity, even if it's just for 2 or 3 years, to bring that a little bit under control, I would say.
Thank you very much, Bruce. Also, thank you, Ilaria and Giovanni, for your comments about looking at data hubs and getting all the people in the net. Definitely valuable contributions. Colleagues, on that note, I would like to firstly thank our first 3 speakers as we conclude this session. Thank you so much, not just for thought-provoking and interesting talks, but also with all the talks in some way linking up with each other, which I think is very valuable. We will then now take a short comfort break, and then we will reconvene sharply at 11 o'clock. Thank you, everybody.
Forestry South Africa is an industry association to represent all timber growers in South Africa. So it serves as a platform for collaboration by the industry on areas of common interest, economic interests, social impacts, environmental impacts and interests of the sector, and then also obviously as an entry point for engaging with government, organised labour, the media, service providers and so on. So there's a vehicle through which people can discuss and collaborate on forestry issues. Sustainability in a forestry context means you need to make sure that your business is sustainable, not just in economic and financial terms, but also in terms of social sustainability and environmental sustainability. We've got a unique positioning in that our sector itself, particularly on the environmental side, has got an excellent track record in terms of environmental conservation. We, for example, only plant 70% of our land holdings, whereas there's no other land user that would give up 30% of its area for the management of conservation and biodiversity. Independently, assessments have been made on the state of indigenous forests and the state of grasslands associated with plantations, and almost invariably our industry comes out on top. So there's a very strong conservation focus in our sector on protecting the areas that are not under timber. One of the most pervasive myths in the environmental discourse in South Africa is that timber plantations use a lot of water. They do not use a lot of water, neither in absolute terms nor in relative terms compared to other sectors. We use 5% of the water used by agriculture, but we return around 27% of agricultural GDP and about the same figure in terms of jobs. And I'm very pleased to say that the High Court found in industry's favour that in actual fact our water use is infinitesimally smaller than what the government officials and the former government hydrologists were maintaining. One should also remember that we use rainwater, so there are no costs to the state to supply water to us. And finally, the water that comes out of plantation areas is of excellent quality compared to that of agriculture or mining. On the social side, our industry is located in rural areas where some of the worst poverty in the country exists. So to have a sector that's providing employment, that's providing a myriad other social returns to education, healthcare, infrastructure is fantastic, and it's something that we're very proud of as a sector. In terms of economic sustainability, we're also quite uniquely placed as a sector in that we are growing our own feedstock. So this is a sector that uses green, renewable, recyclable raw materials that can be produced in perpetuity if we do it in a sustainable manner. This is a sector that really is embedded in the green economy and is a true circular economy sector. Economic recovery is on everybody's lips. As we get the economies back up and running, let's try and focus on those economic activities that can truly be called green, that use natural resources to say these are the kinds of sectors that as a country and as a world we should be focusing on to limit our ongoing impact on the environment. So the concept of the circular economy is trying to manage economic activity by sector from a cradle to grave perspective. Very strong focus on reuse and renewability of products produced. In our sector, we're actually privileged in that we can grow more feedstock. We're not extracting minerals from the ground and dependent on finite resources. The resources we're producing are actually renewable. The other thing, there's the whole world moving away from non-renewable and non-sustainable products like plastic and so on, creates a massive opportunity for the sector to play in that space. So paper packaging, plant-based plastics are typical examples of where the world is moving towards saying we like both renewable but also recyclable products, and this industry is very well positioned to play its role in that space.
Ngitshale izinsiza ezivuselelekayo zemvelo.
That is sustainably managed.
Captures carbon while it is growing.
And stores there until the day we throw it away.
I'm a South African forester.
I am a South African forester.
I'm a South African forester.
I'm a South African forester. We are part of a greener, more sustainable future.
Ngitshalile imizi yamanani aphansi.
Ngitshala upende kanye neglue.
We grow sustainable businesses.
Ngitshalela ukuthuthukisa imiphakathi yasemakhaya.
I grow alternatives to plastic and fossil fuels.
I'm a South African forester. We are part of a greener, more sustainable future.
Forestry South Africa is an industry association to represent all timber growers in South Africa. So it serves as a platform for collaboration by the industry on areas of common interest, economic interests, social impacts, environmental impacts and interests of the sector, and then also obviously as an entry point for engaging with government, organised labour, the media, service providers and so on. So there's a vehicle through which people can discuss and collaborate on forestry issues. Sustainability in a forestry context means you need to make sure that your business is sustainable, not just in economic and financial terms, but also in terms of social sustainability and environmental sustainability. We've got a unique positioning in that our sector itself, particularly on the environmental side, has got an excellent track record in terms of environmental conservation. We, for example, only plant 70% of our land holdings, whereas there's no other land user that would give up 30% of its area for the management of conservation and biodiversity. Independently, assessments have been made on the state of indigenous forests and the state of grasslands associated with plantations, and almost invariably our industry comes out on top. So there's a very strong conservation focus in our sector on protecting the areas that are not under timber. One of the most pervasive myths in the environmental discourse in South Africa is that timber plantations use a lot of water. They do not use a lot of water, neither in absolute terms nor in relative terms compared to other sectors. We use 5% of the water used by agriculture, but we return around 27% of agricultural GDP and about the same figure in terms of jobs. And I'm very pleased to say that the High Court found in industry's favour that in actual fact our water use is infinitesimally smaller than what the government officials and the former government hydrologists were maintaining. One should also remember that we use rainwater, so there are no costs to the state to supply water to us. And finally, the water that comes out of plantation areas is of excellent quality compared to that of agriculture or mining. On the social side, our industry is located in rural areas where some of the worst poverty in the country exists. So to have a sector that's providing employment, that's providing a myriad other social returns to education, healthcare, infrastructure is fantastic, and it's something that we're very proud of as a sector. In terms of economic sustainability, we're also quite uniquely placed as a sector in that we are growing our own feedstock. So this is a sector that uses green, renewable, recyclable raw materials that can be produced in perpetuity if we do it in a sustainable manner. This is a sector that really is embedded in the green economy and is a true circular economy sector. Economic recovery is on everybody's lips. As we get the economies back up and running, let's try and focus on those economic activities that can truly be called green, that use natural resources to say these are the kinds of sectors that as a country and as a world we should be focusing on to limit our ongoing impact on the environment. So the concept of the circular economy is trying to manage economic activity by sector from a cradle to grave perspective. Very strong focus on reuse and renewability of products produced. In our sector, we're actually privileged in that we can grow more feedstock. We're not extracting minerals from the ground and dependent on finite resources. The resources we're producing are actually renewable. The other thing, there's a whole world moving away from non-renewable and non-sustainable products like plastic and so on, creates a massive opportunity for the sector to play in that space. So paper packaging, plant-based plastics are typical examples of where the world is moving towards saying we like both renewable but also recyclable products, and this industry is very well positioned to play its role in that space.
Ngitshale izinsiza ezivuselelekayo zemvelo.
That is sustainably managed.
Captures carbon while it is growing.
And stores there until the day we throw it away.
I'm a South African forester.
I am a South African forester.
I'm a South African forester.
I'm a South African forester. We are part of a greener, more sustainable future.
Ngitshalile imizi yamanani aphansi.
Ngitshala upende kanye neglue.
We grow sustainable businesses.
Ngitshalela ukuthuthukisa imiphakathi yasemakhaya.
I grow alternative to plastic and fossil fuels.
I'm a South African forester. We are part of a greener, more sustainable future.
Welcome back, everybody. I hope everybody enjoyed a refreshing comfort break. We continue with our next session, and it's my privilege to introduce our next guest speaker for the day, Ms. Sunita Kalan, who is from the Department of Science Innovation, where she's the Director of Sector and Local Innovation, has been working with industry for the past 7 years. I've really enjoyed working with Sunita personally. Maybe to introduce a bit better, Sunita is probably the single or the central driver of the Sector Innovation Fund. She's been a government official that's been a pleasure working with. She's supported the industry where she can, and not sure how Sunita, but still Sunita with the DSI was able to secure funding for a 4th round of Sector Innovation Fund, which the forestry sector secured 32.5 million. So over and above saying thank you, Sunita, for your presentation today, and looking forward to your contributions and giving a bit of a government perspective of a department that works quite closely with industry. Also, thank you for your efforts in supporting our research and development landscape with everything you do for us. So on that note, thank you, Sunita, and looking forward to your talk.
Thank you, Ronald. That's a very kind introduction. Good morning, everyone. I am Sunita Kalan. I'm from the Department of Science and Innovation. Sorry, I'm just getting my act together here. Great. I hope you can all see my screen and hear me properly. I am responsible for, amongst other things, the Sector Innovation Fund program at the department. And Ronald asked if I could perhaps give the perspective, the department's perspective on public-private partnerships in research and using the Sector Innovation Fund as an example of how it can be done and to show how it can work. So I'm sorry, something's gone on here. Okay, so I'm going to try and explain, at least from our perspective, why it is important to invest in R&D and innovation, and how a public-private partnership in research can act as an enabler for development and economic growth. I will focus on the Sector Innovation Fund as it is what I am most familiar with, but I will also touch on some other collaborations in the RDI space that the department has that with industry. And I thought I would be a little bit naughty and leave you with some food for thought about why it is important that we have complete information, certainly as government and policymakers, to inform, amongst other things, our engagements with industry and how we can structure those. So I'm going to start with the findings of the R&D survey that were published earlier this year. There's always a roughly 2-year delay with these surveys. So this is up to 2019, 2020. And what this survey showed is that while there is an increase from public sector money into R&D broadly up until 2019, and that, you know, we funded around 56% of that. Industry is the next big funder, but there was a decrease from industry of roughly 25%. Well, and this would be of the business categorization. You know, that there are reasons for that. It's been tough economic times recently, even 2019-20, pre-pandemic and all of that. We were struggling as an economy, so there are reasons. As always, R&D is the first thing to be sacrificed, and that's true both in the public and the private sector. But I thought I would use it to set the context for, you know, why it's becoming important to try and leverage each other's investments into R&D. On both sides, the context is very constrained, and so we do need to be try to find ways where we can work smarter and not just bigger and better as well. So I'm going to kind of hopefully be preaching to the converted here. But there are various documents going back as far as the National System of Innovation Review, that was around 2007-8, that identified the need to invest in research and development, and identified its role in economic growth, recognized that R&D, new knowledge, technology development, all of that has a direct impact on our innovation, our competitiveness, our ability to compete on a global market. At a more local level, it is vital that we develop and capacitate South Africans to participate meaningfully in a knowledge economy that's now become digital and a whole host of other things. But you know, if we're going to take advantage of what all of these developments mean for our country, we need to have a people that can take advantage of the opportunities presented. So we do need to be particularly mindful of developing and capacitating them. And so all of these themes, while they go back as far as 2007-8, they have carried through to the different white papers, including the one that was approved by Cabinet 2-3 years ago. It carries through in the current draft decadal plan that we're hoping will be finalized in the next month or so. And the partnership with business and industry is identified as a key thing we need to take forward for anyone that's been in the innovation space for any amount of time. We often talk about the triple helix, or we used to talk about the triple helix. So in addition to government and academia and business, what is now also important, or what is now finally being recognized as being important, is that we also need to include civil society and communities. So create the multi-helix. And from a DSI perspective, the private sector, business, industry are vital to that effort. Just then, I thought I would give you a little bit of background. So based on all of those reviews, the department had an opportunity through a little pot of money we were lucky enough to receive around 2013 from the Economic Competitiveness Support Program that National Treasury made available after the 2012-13 financial crisis. And what that small pot of money allowed us to do is consider how we can put put in place the recommendations of all of those reviews, that we do need to work more closely with the private sector. We need to have a better relationship with business and industry. And so the department conceptualized two initiatives, the Industry Innovation Partnerships Program and the Technology Localization and Support Program. I'm going to focus on the Industry Innovation Partnerships Program because it is out of that the Sector Innovation Fund arose. And really the idea here was, one, how do we leverage? We recognize that industry was investing in R&D. How do we leverage that through a co-funding relationship so that in the main we can maintain and increase our export market share, but also how do we mitigate the underinvestment we're seeing across different sectors and various sectors in technology and innovation, recognizing that that has key impacts on our competitiveness as a country. We were very, very ambitious, as Ronald will attest. So when we started with this, we were hoping that we would be able to measure how such interventions would contribute to an increased sector contribution to GDP through these R&D and innovation-based industrial development initiatives. We have learned that that's not particularly easy. Even we're now almost 8 years down the line, recognizing, however, that in the R&D space, that's a particularly complicated measure to have because there are so many other dependencies that come into play. We've adapted that a little bit differently in how we measure this, but it was, at least at the start, our hope that we could show it. We are starting to see some trends, but as you all know, I don't need to tell you, this is a long-term goal. It will stay there, but we've also recognized that we need to put in place kind of more medium-term measures in this to show the impact of what we're doing. So I thought I would give you a sense of what the IIP looked like at the start. And there were 6 different initiatives that we put in place. We tried to stimulate the titanium industry, satellites, nano, the ICT space, all of which, most of which is continuing in various forms, some of which we've had to adapt and change. But the 2 areas that fell into kind of direct work with the private sector or trying to stimulate the private sector was the industry development centers we had at the CSIR, and then the Sector Innovation Fund. I shouldn't say had, those centers do still exist at the CSR. We unfortunately are just not able to fund them anymore because we didn't get any further funding beyond, so we funded them up until the end of the last financial year. But essentially those were centers in biomanufacturing, nanomaterials, the biorefinery facility, which I think many of you are familiar with, at the CSR campus in Durban, that Bruce Sitole was instrumental in setting up, the photonics facility, and then we tried something in the nano micro device manufacturing, which didn't work out as well as we'd hoped. But each of those do continue at the CSIR, and they're just funded by different, they're getting funding from different people. But the idea was, how do we use the capacity at the CSIR or at institutions like the CSIR to assist in these instances? We focused very much on kind of trying to bring small players and small business and emerging players into the innovation space. How do we use that capacity at the CSR to do that? There were also quite a few big companies that were working with them. So SAPI worked both with the biorefinery facility, but also they were doing some work with nano. And then the Sector Innovation Fund, which I'll start talking about in a bit of detail. When we started, we had nine industry associations, but that decreased to 7 for reasons I'll get into a bit later. So just to give you a sense of what the SIF is, and I know that's a rather odd acronym, but we are stuck with it. The the intervention is really to try and enhance economic competitiveness of participating sectors. My apologies. How do we create an enabling environment for government and industry to partner to further progress industry relevant innovation priorities? How do we, it was really to try and find new ways to foster those partnerships with the private sector, and also understanding that we needed to build a stronger link between industry and the public science system, so that what we were doing in the public science system was more useful to industry and would facilitate a greater level of uptake. The program is intended to incentivize the private sector to increase its investment in research and development and innovation through what started as a co-investment partnership, but is now a matching funding partnership. And the R&D priorities that industry identifies need to address their competitiveness issues, sustainability issues, and in many instances, how do they maintain and get into new export markets? It is a very deliberate decision on our part to work with industry associations. So the funding from our side goes to organized industry associations that are formal entities. They must show that they represent the interests of their sector. From our side, we participate in the governance structures of each of these associations. And this was quite deliberate on our side, that we would not directly fund the universities or the science councils or researchers directly, because we wanted to try and ensure that the priorities that were identified were from industry and not from academia and the research community. Our objectives really is to try and increase investment from the private sector into research and development and innovation, with the idea that this would improve our general competitiveness. From a DSI perspective, what's key is that we increase the R&D and innovation capacity in that sector. This is very much around human capital development and new knowledge generation. But also from a transformation perspective, I could just perhaps skip a few. It was also about how do we make sure that from a transformation perspective, we're not just transforming the SET base and the research capacity within both the public science system, but also within particular industries. But how do we also then ensure that emerging and small players in a particular sector are also catered for in terms of that R&D need. So to give you a quick sense of the history, we implement this through a call for proposals process. This is not run annually. We run 3 to 4 year programs. So we've historically issued the last call in November, December last year, and we are currently in the 3rd phase of what is a 4-year program. There is a formal self-evaluation panel that is set up that has representation from the DSI, obviously, and the other government departments are identified kind of based on the industry associations that applied and their relevance to those particular sectors. So we have Forestry, Fisheries and the Environment, Department of Agriculture, Rural Land Reform and Rural Development, and then the DTIC as well. And to give you a sense of where we started with our 9 at the start, the 2 you see in red by their own request cancelled their SIFs in the 1st year of operation. The Mufasa, which was the finfish guys, were too small, and they recognized that that they were just not able to meet the requirements because they were just starting up as a sector at the time. MIASA was the boat building association, and their challenge was that it was difficult for them to identify sector-wide needs. The SIF is very much about the sector as opposed to individual companies, and that particular association just struggled to come up with ideas that were cross-cutting and that they were all affected by, that they could implement an R&D program around. In the second, the pilot phase, we, from a DSI perspective, we invested around 122 million rand. The second phase, we saw quite a big drop in our funding, and we only had around 67 million rand available. So we limited our call to the existing portfolio that we were supporting at the time, and all 7 went through. And then with the third phase, which was even tougher than the second, because we as I said, we started this because we had the economic competitiveness funding available. That ended at the end of the second phase. So we really were unable, unfortunately, to gain new money from Treasury for a third phase, but we were lucky enough to secure some donor money for it. So it is much smaller than what we had initially anticipated. We only have 6 associations going forward. The citrus guys, which is CRI, elected at the time not to participate because on the back of the successes they had experienced with the first 2 phases, their industry partners actually increased their research levies, and the Citrus Association decided not to apply for the third phase because they saw such a big significant increase in their research budgets. So they elected not to. And we have a new association, which is the Rooibos Council. We're quite excited to work with them for the first time. And yeah, we'll see where that goes. The third phase, our investment as the department is around 37 million for this particular year. It will, we're investing another roughly 38 million on top of that. So this phase would be equivalent to just a little bit more than the second phase was. Just in terms of how we run these, each one has a steering committee and a technical review committee of some kind. The DSI sits in every steering committee. One, just from an oversight perspective, we require as the department that there is inclusive, active industry participation in all of those committees. We try as far as we can to make sure that includes the emerging and small players. That's worked well with certain industries, but not so much with across the board. As I indicated earlier, we've tried to also involve the relevant line departments in the SIF. So in addition to them sitting on the SIF steering evaluation panel, they also sit in some of the steering committees. So with forestry, as an example, we have representation from DFFE, who also are participating in the Rooibos Council Committee. And then, yeah, the others are as relevant to the particular industries. If I remember correctly, I think DFFE is also participating in the paper manufacturing sector innovation fund with PAMDEV. So I actually need to update this. So in terms of measures, one of the things I wanted to explain that it was quite difficult for us because it's quite a diverse range of sectors, as you would have seen from the previous slide. So we needed to show also or create generic measures that would apply to all of those different sectors. And we've tried to generate a basket of measures at each level of evaluation. What's very important for us is the issue around that these have to be industry relevant. So the skills and the knowledge have to be relevant for industry if we are really to make any kind of difference to competitiveness. So for example, with the HCD basket of measures, while we're supporting the number of students, we're counting the number of students and interns we've supported. What is also important to us is to try and measure the absorptive capacity of those students and interns. The logic being because they're industry relevant skills that we've developed, those students and interns would become more employable within the sector. And I'll talk to that a little bit on the next slide. Similarly, with the knowledge products that we generate, how many of those have been transferred and who have we transferred them to? And obviously from a competitiveness perspective, the co-funding is important to us. We're also trying to measure the number of jobs created, which is not all that easy in this space, but it is something we're giving it a bash to try and do. Just to then give you a sense of our achievements to date. So with the HCD side of things, what's been encouraging for us in terms of our students, and I focused on the students here, but there is a similar trend with our interns. One, from a transformation perspective, both in terms of race and gender, we're making good progress. So we're almost kind of equally represented across both sides of things. We often got told that in a South African context, we find that postgraduate students tend to be older. With the Sector Innovation Fund, we're finding that to be not quite the case. So most of our students from postdoc all the way to undergrad are actually under 35, which is great from a pipeline development perspective. The bulk of our students are also South African, and then the next big proportion of students are from the continent itself. So all of that is quite encouraging to us from a transformation perspective. What is less encouraging is from the research perspective. We're still not seeing as encouraging, or the transformation side of things is still not as encouraging as we would like to see, but we're hoping that we start making good progress with that from the third phase onwards. We're still busy analyzing some of the data from the second phase, so that we can see how we're doing on that. What is also encouraging to us is that at least 20% of the students and interns that we've supported have become employed. That's either within a university situation, research institutions that are which are relevant to a particular sector, or within the sector themselves. We recognize completely, however, that this is not the full picture. It is very difficult for us to start tracking students, or to be able to track students and interns once they've left the program. The POPI Act makes life even more interesting, but even without that, it was really difficult for us to do this. So even with the imperfect data, though, this is quite encouraging for us, because it is showing a useful trend towards whether the industry relevant model works or not. From an increased investment into R&D, with the first two phases, the industry co-funding amounted to 107 million. The DSI invested 182 million. While the second phase was a matching funding requirement, the first phase was not. It just required a minimum level of co-funding, which is why that's not a direct one-to-one. I thought it would be useful just to give you some, particularly to forestry and the paper manufacturing guys. In the first two phases, the DSI invested around 36 million, and we got the industry level got 24 million in co-funding. With paper, it was 10.9 million from the DSI, with the industry co-funding 6.8 million. What we've seen, just also mindful of time, what we have seen here in terms of improved competitiveness, in many instances, what has come out of the Sector Innovation Fund have been key product and process interventions that have been significant to the industry themselves and their competitiveness, because they've resulted in cost savings, operational efficiencies. There's a huge pest and disease control portfolio across at least all the agriculture ones, and in the forestry ones, as we've already seen in the previous presentations and will for the rest of the day. In many instances, what the industry partners also identified was the need to investigate options, technology and innovation options to apologies, the claim, to diversify their products and revenue generation. So for example, with the sugar guys, the first phase of what they were looking at was investigating biorefinery options for the sugar milling waste and some of the sugar milling materials that come into their processes. What they're now investigating in their second phase and going into the third is how do they implement 4IR type principles in their sugar milling processes themselves. So going into the sugar mills, how do you put in place real-time sensing? Is it doable for anyone? I had the opportunity to visit a sugar mill just before the pandemic, and for somebody who has a very sweet tooth, I was horrified at just how sugar gets made from sugarcane. But for me, it was very interesting that they wanted to see if they could put in place all of this high-tech stuff into what is really a rough and a very rough kind of sugar factory environment. And the results from that are proving to be very interesting for us. I quickly then just want to, sorry, Ronald, I am trying to stick to time here. I wanted to also just allude to, or maybe just before I do that, what I wanted to say earlier, having sat through some of the presentations this morning and seeing some of what's coming later on today, I'm seeing some interesting contribution of the SIF portfolio to what is already being done. And I thought maybe what I would also do is just kind of give a run through of what the outcome of those first two phases of the SIF funding has been to the forestry sector. So the FSA has indicated that the funding has allowed for a significant increase in the research portfolio of the sector, and some of the really interesting options that have come out, and some of the really innovations that have come out that have a direct impact on industry have been, as examples, just free to use tools that and mobile apps that the entire industry can access that will improve plantation management, enterprise management, and therefore competitiveness. The pest and disease screening facility that Professor Slippers referred to earlier, that is specific for the forestry sector. And on the back of that, implementing new screening methods for pathogens that are affecting your source material, really. Some very interesting molecular breeding strategies that will feed into developing a precision tree breeding platform. And from my CSR days way back, I know how important that is. I see Steve is here as well, and I remember some of the work that he was doing. So I know that would make a big difference across the sector. You're looking at climate change models and what that would mean in terms of planning and predicting the issues and the solutions that come with the changing weather. So we're seeing that it is making a difference. We're hoping to have a better sense of what that means from a quantifiable perspective, but at least from the DSI side of things, we're seeing that without the DSI funding, you would not have been able to do many of these projects. And so this kind of an enabling environment that we're trying to create with this program has enabled not just forestry, but all of the other sectors to investigate areas you would not otherwise have had funding for, but also start investigating new areas and maybe take a little bit more of a riskier approach to start looking at what is and isn't possible in your spaces, which is really what the intention of this was. I thought I would also touch on our other collaborations with the department's other collaborations with the forestry sector. There is the Forestry Bioeconomy Cluster, which is run from the Technology Innovation Agency, which looks at the molecular genetics situation, molecular genetics portfolio at UPs, a key part of that. And then the SMME support, so really trying to bring new and emerging players into the more downstream value chain of the forestry sector. And that's with the biorefinery facility at the CSIR. While, as I understand it, there isn't industry funding necessarily going into the cluster, the industry has an active participation in the steering committee of this cluster. And then what much more recently was the launch of the biosecurity hub, and what that and how that links to the information and the data that comes from FABI in ICFR and a couple of other institutions within the forestry sector. So I think that's also been, while these aren't necessarily co-funding arrangements, these relationships that the department has with the forestry sector are also going a long way to try and enhance the competitiveness of the sector. And then I thought I would leave it with this. So we do the R&D survey every 2 years as a department through HSRC. What they did for the first time, which was launched also a couple of months ago, was an agricultural business innovation survey. And they looked at agriculture, fisheries, and then forestry as well. And I looked at this and I thought, well, some of this is counterintuitive to what I know from the Sector Innovation Fund. So the findings of this sector was that forestry is really a low-tech industry, that the large firms in the forestry sector are not really innovation active, that much of your innovation is just about process innovation, not product innovation, and a high proportion of forestry enterprises that were surveyed said that they were not innovation active. Now, I already can see Ronald being very upset with these things because I know we've had many discussions about this in the past. But one is, I wanted to present this slide for two reasons. One is to highlight that 303 enterprises were sampled for the survey. Only 34 responded from forestry. And why I wanted to raise this particular issue is that from innovation policy, R&D policy perspective, in many instances, what informs government policy and what informs kind of donor funders and other funding agencies are surveys like these. And this is, the survey was very much, it was done on kind of OECD type of precedents. They followed those methodologies, those kind of questions that are asked. And these are the surveys that influence our global rankings in terms of innovation, competitiveness, and all of those things. I fully recognize that it's not a great sample size, it's not a great response rate, but this is the picture of the forestry sector that comes in the R&D space that comes out, and really to try and say, you know, in addition to kind of the co-funding and those sorts of arrangements, it's also important for our industry partners to participate in these surveys. I know that there was an effort to try and contact industry partners directly. They tried to do that from using the Sector Innovation Fund stakeholders, but also some of the other programs that have direct private sector stakeholders. But I think it's just to make the plea to please think about doing this, think about responding properly. And if you have responded and you found that the questions were misleading or weren't particularly helpful, perhaps to give feedback to the team so that the next time we do this, it will be a more accurate picture of what at least your sector represents, but also the other sectors, but also that it is more meaningful to the reality on the ground. You know, I often say I come from a tech transfer background, that was my previous life. And the one lesson I had to learn very quickly with this portfolio is what we think about in terms of technology transfer traditionally. The linear model, you develop something and then it gets licensed and then you earn royalty income. That's not really how it works in real life and in industry. And similarly, it's important that we get the feedback that we need to make these kind of surveys more meaningful. And Ronald, I think I will leave it at that. Thank you very much for the opportunity.
Thank you so much, Sunita, for the government perspective and really, I think, capturing the SIF over the past 6 years and what it's meant for us, but also what it's meant for government. So thank you for that. Really appreciate it. And yes, I think that survey is quite an interesting response. You know, there's already some comments in the Q&A, but let's look at the Q&A, Sunita. We've got a question from Andrew Morris. He says, the move to matching funding is a good measure to increase private sector R&D support. However, for emerging and small players in the sector, it is intricately more difficult to collectively fund R&D. Do you have any suggestions on addressing this challenge?
Sure. So, Andrew, that's something we've realized as well. What we, and having come from the event earlier this week as well, it kind of reinforced for me that we need to think about how we do this. You know what, and you're absolutely right. It's a lot easier for us to get the co-funding and the matching funding from established industry players. It is less so from the emerging guys. One of the options we're looking at from a sector innovation fund perspective is perhaps we need to reach out to kind of the representative bodies of the smaller players. So for example, while on the horticultural side, we work with the Fresh Produce Exporters Forum, there's the South African Fruit Association, I think they're called, who represent the more smaller players, to see how we can do that. And it might be that we need to have a sliding scale or not quite a matching arrangement. What we try to do, for example, with these centers at the CSIR is require that the established industry players that participate and make use of the facility pay for their services, whereas kind of the public sector funding gets used to subsidize to some extent the smaller players, and when they come back to the facility, they pay some kind of they then start paying for it. I do not have all of the answers, unfortunately, but it is definitely something we're thinking about. And one of the things is perhaps that they look at pooling their resources. I think that at least for the medium term, there will have to be some level of subsidization, at least until we can get people on an equal footing.
Thank you, Sunita. I also think that DSI's decision to work through industry associations alone also does address that. With FSA, for example, representing 20,000 small growers and contributing levies to FSA, they are equitably share or contributing to the R&D expenditure through FSA at least. That's not the biggest chunk of our R&D expenditure, with our corporates direct funding far exceeding what FSA is spending. But at least working through the association, you're getting some of that in the net, which is a very, I think, clever decision to take it at the end and do it that way. Before we close off, I'm going to quickly refer to Giovanni's comments. Giovanni from SAPI, also noting that, he can't recall that survey. And I think maybe collectively, Sunita, we can see how we can get industry more involved in those surveys. And even if we need to assist in communicating that survey to our members, we'll definitely be happy to do so going forward. And then Giovanni just expressing, I think, his gratitude to DSI, saying that SIF funding usually helpful and has borne fruit for our sector. So I think that's a sentiment shared by all, and definitely from myself and FSA as a representative of industry. We really do see value in DSI's contribution through the Sector Innovation Fund. by far the department that invests the most into forest research and development. So really thank you for that. And on that note, Sunila, thank you very much for informative talk and just, I think, conceptualizing where we are with these partnerships between government and industry and how valuable they can be. And we really hope that some of the other departments take this as a lesson learned and try and model their funding on a very similar way going forward. So thank you very much, Sunita.
Thank you. Take care.
Then moving on to our next presenter, I've always said that our sector is very well known for collaborating, and even more so in the next talk. We've got two presenters in the next talk. The first being Professor Jos Loom, who is currently the director of the School of Natural Resources Science Management at Nelson Mandela University, or Old Sarsveld, as a lot of us know it. And he will be partnered by Professor Keith Little, who's associate professor at the school, and really spearheading the NMU's efforts in forest research. And I think over the past few years, we've seen a significant increase in their contribution to our research landscape. So on that note, Jos and Keith, thank you very much for your contribution and presentation today, and talking a bit about capacity and going forward, something that's been raised in two prior talks today. So definitely just linking on again to the need for capacity to ensure our sector's competitiveness and sustainability. Thank you, Jos.
Ladies and gentlemen, good day. It's always an honor to be part of the Forest Science Symposium, and it is always very exciting to discuss the role of tertiary education in the forestry environment. So the title of our talk deals with building capacity as a foundation for the future, and I would like to acknowledge the inputs of my colleague Professor Keith Little into the content of this presentation. So as academics, we are constantly busy with strategic analyses and planning, and we certainly have to keep a watchful eye on international trends in the forestry environment. And one very important aspect is covered by the enclosed report. I'm just going to provide a very brief summary. It is quite clear that the role of forests are becoming much more diverse than in the past. It lies central to the vision of a prosperous and inclusive society that strives towards living within planetary boundaries. And in many ways, it is becoming part of the green economy through very innovative business models. There's definitely a shift in employment patterns. On the downside, there are many losses due to mechanization. This is an international trend. But fortunately, there are many new careers related to innovation in wood-based products, new generation circular business models. And this is very often linked to aspects of ecosystem rehabilitation, certification schemes, recycling, and even different secondary uses of forest products. And it is very clear that ecosystem services are increasingly valued by society, especially in Western Europe and the US. And downstream services feature much more prominently. So aspects such as environmental education, personal health, environmental health, recreation, and tourism are becoming increasingly important. So all indications are there that we will need a much more diversified and skilled and motivated workforce. So in response to this, universities are diversifying education qualifications, curricula, as well as the modes of teaching and learning. One will be amazed if you look at the new academic programs on the international market, master's degrees in forestry, environmental engineering. I've seen an advert for a master's in creative sustainability. There are definitely new modules being incorporated into curricula, often dealing with aspects of the fourth industrial revolution, including aspects of high technology. And then also the teaching and learning methods are changing quite radically, towards more problem-based learning and away from the conventional way of teaching and learning. So the evolving labor markets will most certainly influence the required competencies as well as the learning outcomes. And progressive universities who move very close to industry are very much aware of this. And through systems of advisory boards and those types of mechanisms, one has to be dynamic, and you have to constantly upgrade your curricula to stay relevant and responsive to industry needs. Now, South Africa is fortunate to have an abundant supply of graduates. And this graph indicates, the top line indicates the total number of graduates over a specific time period. This is from, I think it is 2005 to 2019. And you can see the differentiation there for three different major universities, NMU, Stellenbosch, and Fort Cox. And it is very clear that we don't have a shortage of graduates. And this is in stark contrast to many other countries where bachelor's degrees in forestry had to close down because of non-viability. Another important trend is the role of the defined sustainability development goals of the UN. One would like to believe that this has been formulated based on consensus by the brightest minds around. And nowadays, strategic development goals form a very important moral compass and the framework in societies strive towards sustainable living. And we as foresters can feel quite at home and orientated within this framework because the big five are all there: food, water, climate, energy, and biodiversity. Now, the international ranking of universities always attracts attention. I mean, annually, it is quite an important publication to see how your alma mater actually performs, and alumni always track these with great interest. And traditionally, universities are internationally ranked based on its research performance, its research outputs, the impact factors, and you know, the number of external contract and the values of those. And that was quite a conventional model that resulted in universities like Oxford, Cambridge, MIT, Yale, and those ones always featuring and dominating the top 5 positions. But in more recent times, a very important rating system is a Times Higher Education rating system. It shows us that society nowadays look through different lenses at the relevance and the status of universities. There's been a shift towards using sustainability development goals in rating the relevance of universities. Research is still important, but there's greater emphasis on teaching and industry engagement initiatives as well. And this is certainly going to provide a different perspective on how society views the relevance of universities. Now, another important trend to take note of is covered by this very interesting article by the World Economic Forum, where they asked the question, what are the top 10 skills most valued by the world of work? And this is covered in the form of a time sequence from the year 2015 to a futuristic view of what will be the top 10 skills for the year 2030. And one can clearly see some new concepts and terminology featuring. And it is very clear that multidisciplinarity and systems analysis and understanding the interconnectedness of things, understanding cause-effect relationships will become much more important. And universities must certainly take note of these, and elements of this must be built into academic programs to make it more responsive to industry needs. So that brings us to a very important question. Does tertiary education in South Africa equip professional foresters for the future? This is a paper that was published in our Southern Forests Journal by Palesa Hamgaga, supervised by Professor Mary Schools from Wits University. So I just want to draw your attention to 2 important graphs. The first one deals with employers' ratings of the importance of certain forestry subject areas, and then the vertical bars will also include the performance of new graduates in those respective fields. And it is quite clear that the expectations and the value that industry attach to certain subject areas are very much out of line with the performance of graduates. I mean, just look at this disparity between forest bioenergy and what the industry actually expects. And the same is true for carbon sequestration. And I'm very surprised to see elements of biodiversity and forest ecology and forest health as well. In a similar fashion, employers' ratings of non-technical competencies and the performance of new graduates. And things like written communication skills, it is highly valued by industry, but new graduates perform quite dismally. The same for oral presentation skills and aspects such as the ability to plan and execute tasks independently, or an appropriate approach to problem solving, and other things like leadership and understanding economics and critical and analytical abilities as well. There are, of course, many other trends to take note of, but we don't have the luxury of time to discuss them in detail. But we can't have this discussion without referring to the role of climate change. You know, climate is one of the great concerns of our time, and it is certainly a mega trend that will shape the future of society. Also, foresters are acutely aware of the fact that we are dealing with a limited resource. It is unlikely to expand significantly in size, and due to the geographic location and the ecological context, there will always be issues related to water and biodiversity and even land availability. And forestry will always have to justify its land use against those parameters. So we know that the solutions will be complex. They will most definitely be interdisciplinary in nature through skillful integration of business, society, and the biophysical environment. But let's not forget that these new developments and trends will always bring new entrepreneurial opportunities and a new economy. Now, it is interesting to take note of the vision statements of the various universities, which are freely available on the internet. NMU refers to sustainable futures. Stellenbosch University refers to a research-intensive university, recognized as excellent, inclusive, and innovative in service of society. University of Venda refers to engaged scholarship, and Fort Cox Institute make a statement about sustainable agriculture and forestry in accordance with dynamic and ever-changing needs of the sector. So one would like to believe that these statements are a true reflection of the identity of these universities. So if we look at our South African higher education's qualifications framework, specifically at forestry education, on the left-hand side of the screen, you will see the various national qualifications framework levels, and then an outline of our 5 existing forestry programs offered by 5 universities. Some universities, of course, accommodate programs from graduate right to PhD level. Others only focus on graduate levels, and others only on postgrad levels. But it is important that to take note that our industry is very well serviced through a variety of academic programs. And according to the framework, there is possibilities of articulation. Students can move across different universities to study at higher levels. Now, of course, this is generally a good thing. It is good that graduates are exposed to different types of environments, different types of teaching and learning techniques, and different ways of thinking about forest science. Now, the forestry education environment is quite a competitive one. Each university would like to attract the brightest minds, but it is very important that we collaborate on curriculum design to streamline articulation and student mobility. You know, collaboration on curriculum design is very important, and it must not only be on the content. You know, we mustn't offer the same content, but at least we have to collaborate on the design and the standards of teaching and learning and research, so that these programs actually complement each other. Now, a project to certainly take note of is the Forest 21 project. This is a European Union sponsored project with the title 21st Century Climate Smart Forestry Education for Livelihood and Sustainability in South Africa. Now, the consortium consists of 5 South African universities and then 2 from Finland, HAMK and Aalto, and 1 from Norway, the Inland Norway University of Applied Sciences. Now, our Nordic partners are internationally acknowledged, for their innovation and excellence in teaching and learning methods. So this is the first project of its kind. It is very, very ambitious, and it's got the potential to change the face of forestry education in our country for good. If we look at the objectives, it is very much focused on the revision of existing curricula with the specific intention to include climate-smart management aspects with a very strong focus on entrepreneurship. And then the conventional way of teaching and learning must be replaced by what we call problem-based learning. And this is very much focused on multidisciplinarity and the analysis of complex environments, and then the need to create a community of work, even beyond the lifespan of this project, where there is much closer collaboration between our relevant universities as well as international partners. And eventually, the intention is to strengthen our capacity for pedagogical methodology, through these various partnerships. So I would like to make a few closing statements and comments about the role of research at universities. We all realize that as part of an academic organization, we have a responsibility in terms of producing postgrad students capable of fulfilling future research needs within Southern Africa. Now, it is a well-known fact that most universities experience financial difficulties. And if you ever think that a research program will get you out of financial trouble, you quite likely make a very big mistake. If you want to engage in research for the wrong reasons, your misery will just continue. So we have to do research for the right reasons. And if success is your goal, you will need a rigorous research management process aimed at eliminating dropout, reducing the time to completion, reducing lack of direction, ensuring adequate funding, and ensuring optimal use of supervisors. So we need increased postgrad supervision capacity. Staff must be properly qualified. They need specific skill in how to supervise postgrad students. We need industry networks. We need research associates to serve as co-supervisors for these postgrad students. And of course, funding, the funding base must be expanded. At the moment, we are very privileged, to have significant funding for research coming from Forestry South Africa, the FPM SETA, even internal university bursary schemes, the National Research Foundation, and also direct funding coming from industry. Now, going back to some of my earlier arguments, our view is that the role of the MSc mustn't only be seen as the quality of the end product. It is very much also the journey that the student undertook to reach that destination. So the core skills required for research will always remain important. I mean, if you look at things like domain knowledge, data collection skills, generating research outputs, and all those kind of things, it will always be of primary importance. But it is also important that the candidates develop some professional and personal skills as well in terms of communication, the financial management aspects of the project, IT skills, numerical skills, and so forth. And I always maintain the philosophy that doing an MSc or a PhD is not only for a research career. Very often it is also relevant to middle and high level managers, because managers require analytical skills and a sense of judgment that is appropriate at that level of management. So in conclusion, I really think we should embrace the exponential age. It is an absolutely great time to be part of tertiary education. We will see a rapid transformation in the work environment as well as market requirements. And I think the forestry industry should exploit the green economy and the value that society puts on ecosystem services. The required skills will change as well, from conventional to multidisciplinarity. In response to this, universities will have to critically analyze their existing curricula And through innovation and creativity, we must reimagine academic programs as well as academic outcomes. It's important that we foster a competitive spirit. There must be a sense of urgency towards employability and professional relevance at all levels of study. And in the end, the fourth industrial revolution will not only impact on what we do, but also who we are. And I think it's going to have a profound influence on our own unique identity. So I would like to leave you with this very interesting image. It says, don't prepare students for something, prepare them for anything. So that was me. I thank you for your time.
Yes, thank you very much for capturing the essence and the need to focus on our graduates and the capacity that we will rely on going forward. I'm going to start off with one question in the Q&A from Ulrich Rechter. He asks, are there any stats showing how many of our graduates are employed by South African forestry companies and how many immigrate to work in foreign countries? Is South Africa gaining or losing young forestry professionals?
Thanks for that question, Ulrich. Until recently, just shortly before the COVID pandemic hit us, we had very accurate stats about employment figures of our graduates. And from NMU's perspective, we had very close to 100% placement record within 6 months of graduates leaving the campus. That was quite extraordinary. And in the case of wood technology, for instance, the demand was something like 3 times more the number of graduates. But of course, COVID came and things got a little bit muddled up. There are currently large numbers of graduates not being employed. We don't have exact figures for that. And then, of course, tracking graduates moving internationally, we don't have that either. So maybe through our advisory boards, we can create a system, that can actually give us that accurate stats, because I think for decision making and for deciding, at what level do we have to cap our programs, we need the numbers for informed decision making. So we might decide to reintroduce an accurate system to track the movements of our graduates.
Thank you, Jos. I can maybe also add, Professor Maton at Crest, based at Stellenbosch, is actually currently doing a tracer study to look at employment of students, mostly postgraduate students. But I think that will add to the data we're looking for. But I think, as Jos said, we definitely need to get a grasp on this, especially keeping in mind a recent survey that FSA has done through Norman Blamini. We found that there's at the moment 162 forestry graduates unemployed and not been able to find work. And these are interesting trends to pick up. Yours is another question from Mary, and looking at the time, the last question for this session. She says most of her 19 postgraduates are employed in South Africa industry. 2 have moved into NGOs and 2 have left the country. So I think those are also quite excellent figures, Mary. But I think adds to what Jos said about the employment of these students at NMU. We've reached the end of this session. Jos, thank you very much once again for your and Keith's contributions. And before we go on a lunch break, also once again, just thank you to Sunita and the 3 speakers for this session. Once again, really informative and giving us a lot of food to think about. We will then break now for a lunch break. I see there's some comments coming into the Q&A. Maybe just one from Damien, which says we need to make forestry an attractive and diverse career choice with a multitude of possible careers. The traditional view of forestry as a career needs a paradigm shift. Damien, thank you for that. And I can see Katie on the other side smiling. This is something she's been driving very hard through FSA's communication activities, making it, showing the stakeholders out there and the public in general that forestry is firstly not a male-dominated industry anymore, and it's extremely diverse. And Katie have led some nice initiatives this year, and we'll continue as FSA to share that message and promote our sector as a sector for employment. Everybody, thank you very much for the second session. We will now break for lunch and we'll start promptly at 1 o'clock. Wayne will take over the facilitation from after lunch from our side. Just in advance, I'd like to apologize. I need to leave today's event, unfortunately, at 2 o'clock shop. We have a master plan executive oversight committee meeting with the deputy minister, which unfortunately have to attend. But seeing that last time I will have the floor before handing over to Wayne. Just my thank you to everybody for participating, for the presenters, and thank you to Wayne and the SIF for partnering with FSA on this wonderful initiative. Thank you very much.
Yeah, thanks, Ronald. Yeah, I just want to remind everybody of the exciting session coming up just after lunch. So it's quite a nice break. We start again at 1 o'clock, so don't disappear, because we have Zander Marburg, Jakob Kraus, and Tadeda Apetu that will take us into the afternoon session, and we should be done by just after 2. So see you a little bit later. Thanks very much.
Ngitshalile imizi yamanani aphansi.
I grow medicines and cosmetics.
I grow designer dresses.
Ngitshala izakhi ezinempilo.
I grow alternative to plastic and fossil fuels.
I grow sweetener.
Ngitshala upende kanye neglue.
We grow sustainable businesses.
Ngitshalela ukuthuthukisa imiphakathi yasemakhaya.
Ngitshale imisebenzi engapheli yemindeni ephilisa imindeni yasemakhaya.
I grow libraries full of books.
Ngitshale utshalo mali eNingizimu Afrika.
I grow kitchen cabinets and recyclable packaging.
Ngitshale izinsiza ezivuselelekayo zemvelo.
That is sustainably managed.
Captures carbon while it is growing.
And stores there until the day we throw it away.
I'm a South African forester.
I am a South African forester.
I'm a South African forester.
I'm a South African forester. We are part of a greener, more sustainable future.
Ngitshale izinsiza ezivuselelekayo zemvelo.
That is sustainably managed.
Captures carbon while it is growing.
And stores there until the day we throw it away.
I'm a South African forester.
I am a South African forester.
I'm a South African forester.
I'm a South African forester. We are part of a greener, more sustainable future.
Forestry South Africa is an industry association to represent all timber growers in South Africa. So it serves as a platform for collaboration by the industry on areas of common interest, economic interests, social impacts, environmental impacts and interests of the sector, and then also obviously as an entry point for engaging with government, organised labour, the media, service providers and so on. So there's a vehicle through which people can discuss and collaborate on forestry issues. Sustainability in a forestry context means you need to make sure that your business is sustainable, not just in economic and financial terms, but also in terms of social sustainability and environmental sustainability. We've got a unique positioning in that our sector itself, particularly on the environmental side, has got an excellent track record in terms of environmental conservation. We, for example, only plant 70% of our land holdings, whereas there's no other land user that would give up 30% of its area for the management of conservation and biodiversity. Independently, assessments have been made on the state of indigenous forests and the state of grasslands associated with plantations, and almost invariably our industry comes out on top. So there's a very strong conservation focus in our sector on protecting the areas that are not under timber. One of the most pervasive myths in the environmental discourse in South Africa is that timber plantations use a lot of water. They do not use a lot of water, neither in absolute terms nor in relative terms compared to other sectors. We use 5% of the water used by agriculture, but we return around 27% of agricultural GDP and about the same figure in terms of jobs. And I'm very pleased to say that the High Court found in industry's favour that in actual fact our water use is infinitesimally smaller than what the government officials and the former government hydrologists were maintaining. One should also remember that we use rainwater, so there are no costs to the state to supply water to us. And finally, the water that comes out of plantation areas is of excellent quality compared to that of agriculture or mining. On the social side, our industry is located in rural areas where some of the worst poverty in the country exists. So to have a sector that's providing employment, that's providing a myriad other social returns to education, healthcare, infrastructure is fantastic, and it's something that we're very proud of as a sector. In terms of economic sustainability, we're also quite uniquely placed as a sector in that we are growing our own feedstock. So this is a sector that uses green, renewable, recyclable raw materials that can be produced in perpetuity if we do it in a sustainable manner. This is a sector that really is embedded in the green economy and is a true circular economy sector. Economic recovery is on everybody's lips. As we get the economies back up and running, let's try and focus on those economic activities that can truly be called green, that use natural resources to say these are the kinds of sectors that as a country and as a world we should be focusing on to limit our ongoing impact on the environment. So the concept of the circular economy is trying to manage economic activity by sector from a cradle to grave perspective. Very strong focus on reuse and renewability of products produced. In our sector, we're actually privileged in that we can grow more feedstock. We're not extracting minerals from the ground and dependent on finite resources. The resources we're producing are actually renewable. The other thing, there's the whole world moving away from non-renewable and non-sustainable products like plastic and so on, creates a massive opportunity for the sector to play in that space. So paper packaging, plant-based plastics are typical examples of where the world is moving towards saying we like both renewable but also recyclable products, and this industry is very well positioned to play its role in that space.
Ngitshalile imizi yamanani aphansi.
Ngitshala upende kanye negloom.
We grow sustainable businesses.
Ngitshalela ukuthuthukisa imiphakathi yasemakhaya.
I grow alternative to plastic and fossil fuels.
I'm a South African forester. We are part of a greener, more sustainable future.
Ngitshalile imizi yamanani aphansi.
I grow medicines and cosmetics.
I grow designer dresses.
Ngitshala izakhi ezinempilo.
I grow alternative to plastic and fossil fuels.
I grow sweetener.
Ngitshala upende kanye negloom.
We grow sustainable businesses.
Ngitshalela ukuthuthukisa imiphakathi yasemakhaya.
Ngitshale imisebenzi engapheli yemndeni ephilisa imindeni yasemakhaya.
I grow libraries full of books.
Ngitshale utshalo mali eningizimu Afrika.
I grow kitchen cabinets and recyclable packaging.
Ngitshale izinsiza ezivuselelekayo zemvelo.
That is sustainably managed.
Captures carbon while it is growing.
And stores there until the day we throw it away.
I'm a South African forester.
I am a South African forester.
I'm a South African forester.
I'm a South African forester. We are part of a greener, more sustainable future.
Ngitshale izinsiza ezivuselelekayo zemvelo.
That is sustainably managed.
Captures carbon while it is growing.
And stores there until the day we throw it away.
I'm a South African forester.
I am a South African forester.
I'm a South African forester.
I'm a South African forester. We are part of a greener, more sustainable future.
Forestry South Africa is an industry association to represent all timber growers in South Africa. So it serves as a platform for collaboration by the industry on areas of common interest, economic interests, social impacts, environmental impacts and interests of the sector, and then also obviously as an entry point for engaging with government, organised labour, the media, service providers and so on. So there's a vehicle through which people can discuss and collaborate on forestry issues. Sustainability in a forestry context means you need to make sure that your business is sustainable, not just in economic and financial terms, but also in terms of social sustainability and environmental sustainability. We've got a unique positioning in that our sector itself, particularly on the environmental side, has got an excellent track record in terms of environmental conservation. We, for example, only plant 70% of our land holdings, whereas there's no other land user that would give up 30% of its area for the management of conservation and biodiversity. Independently, assessments have been made on the state of indigenous forests and the state of grasslands associated with plantations, and almost invariably our industry comes out on top. So there's a very strong conservation focus in our sector on protecting the areas that are not under timber. One of the most pervasive myths in the environmental discourse in South Africa is that timber plantations use a lot of water. They do not use a lot of water, neither in absolute terms nor in relative terms compared to other sectors. We use 5% of the water used by agriculture, but we return around 27% of agricultural GDP and about the same figure in terms of jobs. And I'm very pleased to say that the High Court found in industry's favour that in actual fact our water use is infinitesimally smaller than what the government officials and the former government hydrologists were maintaining. One should also remember that we use rainwater, so there are no costs to the state to supply water to us. And finally, the water that comes out of plantation areas is of excellent quality compared to that of agriculture or mining. On the social side, our industry is located in rural areas where some of the worst poverty in the country exists. So to have a sector that's providing employment, that's providing a myriad other social returns to education, healthcare, infrastructure is fantastic, and it's something that we're very proud of as a sector. In terms of economic sustainability, we're also quite uniquely placed as a sector in that we are growing our own feedstock. So this is a sector that uses green, renewable, recyclable raw materials that can be produced in perpetuity if we do it in a sustainable manner. This is a sector that really is embedded in the green economy and is a true circular economy sector. Economic recovery is on everybody's lips. As we get the economies back up and running, let's try and focus on those economic activities that can truly be called green, that use natural resources to say these are the kinds of sectors that as a country and as a world we should be focusing on to limit our ongoing impact on the environment. So the concept of the circular economy is trying to manage economic activity by sector from a cradle to grave perspective. Very strong focus on reuse and renewability of products produced. In our sector, we're actually privileged in that we can grow more feedstock. We're not extracting minerals from the ground and dependent on finite resources. The resources we're producing are actually renewable. The other thing, there's the whole world moving away from non-renewable and non-sustainable products like plastic and so on, creates a massive opportunity for the sector to play in that space. So paper packaging, plant-based plastics are typical examples of where the world is moving towards saying we like both renewable but also recyclable products, and this industry is very well positioned to play its role in that space.
Ngitshalile imizi yamanani aphansi.
Ngitshala upende kanye neglue.
We grow sustainable businesses.
Ngitshalela ukuthuthukisa imiphakathi yasemakhaya.
I grow alternative to plastic and fossil fuels.
I'm a South African forester. We are part of a greener, more sustainable future.
Ngitshalile imizi yamanani aphansi.
I grow medicines and cosmetics.
I grow designer dresses.
Ngitshala izakhi ezinempilo.
I grow alternative to plastic and fossil fuels.
I grow sweetener.
Ngitshala upende kanye neglue.
We grow sustainable businesses.
Ngitshalela ukuthuthukisa imiphakathi yasemakhaya.
Ngitshale imisebenzi engapheli yemndeni ephilisa imindeni yasemakhaya.
I grow libraries full of books.
Ngitshale utshalo mali eningizimu Afrika.
I grow kitchen cabinets and recyclable packaging.
Ngitshale izinsiza ezivuselelekayo zemvelo.
That is sustainably managed.
Captures carbon while it is growing.
And stores there until the day we throw it away.
I'm a South African forester.
I am a South African forester.
I'm a South African forester.
I'm a South African forester. We are part of a greener, more sustainable future.
Ngitshale izinsiza ezivuselelekayo zemvelo.
That is sustainably managed.
Captures carbon while it is growing.
And stores there until the day we throw it away.
I'm a South African forester.
I am a South African forester.
I'm a South African forester.
I'm a South African forester. We are part of a greener, more sustainable future.
Forestry South Africa is an industry association to represent all timber growers in South Africa. So it serves as a platform for collaboration by the industry on areas of common interest, economic interests, social impacts, environmental impacts and interests of the sector, and then also obviously as an entry point for engaging with government, organised labour, the media, service providers and so on. So there's a vehicle through which people can discuss and collaborate on forestry issues. Sustainability in a forestry context means you need to make sure that your business is sustainable, not just in economic and financial terms, but also in terms of social sustainability and environmental sustainability. We've got a unique positioning in that our sector itself, particularly on the environmental side, has got an excellent track record in terms of environmental conservation. We, for example, only plant 70% of our land holdings, whereas there's no other land user that would give up 30% of its area for the management of conservation and biodiversity. Independently, assessments have been made on the state of indigenous forests and the state of grasslands associated with plantations, and almost invariably our industry comes out on top. So there's a very strong conservation focus in our sector on protecting the areas that are not under timber. One of the most pervasive myths in the environmental discourse in South Africa is that timber plantations use a lot of water. They do not use a lot of water, neither in absolute terms nor in relative terms compared to other sectors. We use 5% of the water used by agriculture, but we return around 27% of agricultural GDP and about the same figure in terms of jobs. And I'm very pleased to say that the High Court found in industry's favour that in actual fact our water use is infinitesimally smaller than what the government officials and the former government hydrologists were maintaining. One should also remember that we use rainwater, so there are no costs to the state to supply water to us. And finally, the water that comes out of plantation areas is of excellent quality compared to that of agriculture or mining. On the social side, our industry is located in rural areas where some of the worst poverty in the country exists. So to have a sector that's providing employment, that's providing a myriad other social returns to education, healthcare, infrastructure is fantastic, and it's something that we're very proud of as a sector. In terms of economic sustainability, we're also quite uniquely placed as a sector in that we are growing our own feedstock. So this is a sector that uses green, renewable, recyclable raw materials that can be produced in perpetuity if we do it in a sustainable manner. This is a sector that really is embedded in the green economy and is a true circular economy sector. Economic recovery is on everybody's lips. As we get the economies back up and running, let's try and focus on those economic activities that can truly be called green, that use natural resources to say these are the kinds of sectors that as a country and as a world we should be focusing on to limit our ongoing impact on the environment. So the concept of the circular economy is trying to manage economic activity by sector from a cradle to grave perspective. Very strong focus on reuse and renewability of products produced. In our sector, we're actually privileged in that we can grow more feedstock. We're not extracting minerals from the ground and dependent on finite resources. The resources we're producing are actually renewable. The other thing, there's the whole world moving away from non-renewable and non-sustainable products like plastic and so on, creates a massive opportunity for the sector to play in that space. So paper packaging, plant-based plastics are typical examples of where the world is moving towards saying we like both renewable but also recyclable products, and this industry is very well positioned to play its role in that space.
Ngitshalile imizi yamanani aphansi.
Ngitshala upende kanye negloom.
We grow sustainable businesses.
Ngitshalela ukuthuthukisa imiphakathi yasemakhaya.
I grow alternative to plastic and fossil fuels.
I'm a South African forester. We are part of a greener, more sustainable future.
Ngitshalile imizi yamanani aphansi.
I grow medicines and cosmetics.
I grow designer dresses.
Ngitshala izakhi ezinempilo.
I grow alternative to plastic and fossil fuels.
I grow sweetener.
Ngitshala upende kanye negloom.
We grow sustainable businesses.
Ngitshalela ukuthuthukisa imiphakathi yasemakhaya.
Ngitshale imisebenzi engapheli yemndeni ephilisa imindeni yasemakhaya.
I grow libraries full of books.
Ngitshale utshalo mali eningizimu Afrika.
I grow kitchen cabinets and recyclable packaging.
Ngitshale izinsiza ezivuselelekayo zemvelo.
That is sustainably managed.
Captures carbon while it is growing.
And stores there until the day we throw it away.
I'm a South African forester.
I am a South African forester.
I'm a South African forester.
I'm a South African forester. We are part of a greener, more sustainable future.
Ngitshale izinsiza ezivuselelekayo zemvelo.
That is sustainably managed.
Captures carbon while it is growing.
And stores there until the day we throw it away.
I'm a South African forester.
I am a South African forester.
I'm a South African forester.
I'm a South African forester. We are part of a greener, more sustainable future.
Forestry South Africa is an industry association to represent all timber growers in South Africa. So it serves as a platform for collaboration by the industry on areas of common interest, economic interests, social impacts, environmental impacts and interests of the sector, and then also obviously as an entry point for engaging with government, organised labour, the media, service providers and so on. So there's a vehicle through which people can discuss and collaborate on forestry issues. Sustainability in a forestry context means you need to make sure that your business is sustainable, not just in economic and financial terms, but also in terms of social sustainability and environmental sustainability. We've got a unique positioning in that our sector itself, particularly on the environmental side, has got an excellent track record in terms of environmental conservation. We, for example, only plant 70% of our land holdings, whereas there's no other land user that would give up 30% of its area for the management of conservation and biodiversity. Independently, assessments have been made on the state of indigenous forests and the state of grasslands associated with plantations, and almost invariably our industry comes out on top. So there's a very strong conservation focus in our sector on protecting the areas that are not under timber. One of the most pervasive myths in the environmental discourse in South Africa is that timber plantations use a lot of water. They do not use a lot of water, neither in absolute terms nor in relative terms compared to other sectors. We use 5% of the water used by agriculture, but we return around 27% of agricultural GDP and about the same figure in terms of jobs. And I'm very pleased to say that the High Court found in industry's favour that in actual fact our water use is infinitesimally smaller than what the government officials and the former government hydrologists were maintaining. One should also remember that we use rainwater, so there are no costs to the state to supply water to us. And finally, the water that comes out of plantation areas is of excellent quality compared to that of agriculture or mining. On the social side, our industry is located in rural areas where some of the worst poverty in the country exists. So to have a sector that's providing employment, that's providing a myriad other social returns to education, healthcare, infrastructure is fantastic, and it's something that we're very proud of as a sector. In terms of economic sustainability, we're also quite uniquely placed as a sector in that we are growing our own feedstock. So this is a sector that uses green, renewable, recyclable raw materials that can be produced in perpetuity if we do it in a sustainable manner. This is a sector that really is embedded in the green economy and is a true circular economy sector. Economic recovery is on everybody's lips. As we get the economies back up and running, let's try and focus on those economic activities that can truly be called green, that use natural resources to say these are the kinds of sectors that as a country and as a world we should be focusing on to limit our ongoing impact on the environment. So the concept of the circular economy is trying to manage economic activity by sector from a cradle to grave perspective. Very strong focus on reuse and renewability of products produced. In our sector, we're actually privileged in that we can grow more feedstock. We're not extracting minerals from the ground and dependent on finite resources. The resources we're producing are actually renewable. The other thing, there's the whole world moving away from non-renewable and non-sustainable products like plastic and so on, creates a massive opportunity for the sector to play in that space. So paper packaging, plant-based plastics are typical examples of where the world is moving towards saying we like both renewable but also recyclable products, and this industry is very well positioned to play its role in that space.
Ngitshalile imizi yamanani aphansi.
Ngitshala upende kanye negloom.
We grow sustainable businesses.
Ngitshalela ukuthuthukisa imiphakathi yasemakhaya.
I grow alternative to plastic and fossil fuels.
I'm a South African forester. We are part of a greener, more sustainable future.
Ngitshalile imizi yamanani aphansi.
I grow medicines and cosmetics.
I grow designer dresses.
Ngitshala izakhi ezinempilo.
I grow alternative to plastic and fossil fuels.
I grow sweetener.
Ngitshala upende kanye negloom.
We grow sustainable businesses.
Ngitshalela ukuthuthukisa imiphakathi yasemakhaya.
Ngitshale imisebenzi engapheli yemndeni ephilisa imindeni yasemakhaya.
I grow libraries full of books.
Ngitshale utshalo mali eningizimu Afrika.
I grow kitchen cabinets and recyclable packaging.
Ngitshale izinsiza ezivuselelekayo zemvelo.
That is sustainably managed.
Captures carbon while it is growing.
And stores there until the day we throw it away.
I'm a South African forester.
I am a South African forester.
I'm a South African forester.
I'm a South African forester. We are part of a greener, more sustainable future.
Ngitshale izinsiza ezivuselelekayo zemvelo.
That is sustainably managed.
Captures carbon while it is growing.
And stores it there until the day we throw it away.
I'm a South African forester.
I am a South African forester.
I'm a South African forester.
I'm a South African forester. We are part of a greener, more sustainable future.
Forestry South Africa is an industry association to represent all timber growers in South Africa. So it serves as a platform for collaboration by the industry on areas of common interest, economic interests, social impacts, environmental impacts and interests of the sector, and then also obviously as an entry point for engaging with government, organised labour, the media, service providers and so on. So it's a vehicle through which people can discuss and collaborate on forestry issues. Sustainability in a forestry context means you need to make sure that your business is sustainable, not just in economic and financial terms, but also in terms of social sustainability and environmental sustainability. We've got a unique positioning in that our sector itself, particularly on the environmental side, has got an excellent track record in terms of environmental conservation. We, for example, only plant 70% of our land holdings, whereas there's no other land user that would give up 30% of its area for the management of conservation and biodiversity. Independently, assessments have been made on the state of indigenous forests and the state of grasslands associated with plantations, and almost invariably our industry comes out on top. So there's a very strong conservation focus in our sector on protecting the areas that are not under timber. One of the most pervasive myths in the environmental discourse in South Africa is that timber plantations use a lot of water. They do not use a lot of water, neither in absolute terms nor in relative terms compared to other sectors. We use 5% of the water used by agriculture, but we return around 27% of agricultural GDP and about the same figure in terms of jobs. And I'm very pleased to say that the High Court found in industry's favour that in actual fact our water use is infinitesimally smaller than what the government officials and the former government hydrologists were maintaining. One should also remember that we use rainwater, so there are no costs to the state to supply water to us. And finally, the water that comes out of plantation areas is of excellent quality compared to that of agriculture or mining. On the social side, our industry is located in rural areas where some of the worst poverty in the country exists. So to have a sector that's providing employment, that's providing a myriad other social returns to education, healthcare, infrastructure is fantastic, and it's something that we're very proud of as a sector. In terms of economic sustainability, we're also quite uniquely placed as a sector in that we are growing our own feedstock. So this is a sector that uses green, renewable, recyclable raw materials that can be produced in perpetuity if we do it in a sustainable manner. This is a sector that really is embedded in the green economy and is a true circular economy sector. Economic recovery is on everybody's lips. As we get the economies back up and running, let's try and focus on those economic activities that can truly be called green, that use natural resources to say these are the kinds of sectors that as a country and as a world we should be focusing on to limit our ongoing impact on the environment. So the concept of the circular economy is trying to manage economic activity by sector from a cradle to grave perspective. Very strong focus on reuse and renewability of products produced. In our sector, we're actually privileged in that we can grow more feedstock. We're not extracting minerals from the ground and dependent on finite resources. The resources we're producing are actually renewable. The other thing, there's the whole world moving away from non-renewable and non-sustainable products like plastic and so on, creates a massive opportunity for the sector to play in that space. So paper packaging, plant-based plastics are typical examples of where the world is moving towards saying we like both renewable but also recyclable products, and this industry is very well positioned to play its role in that space.
Okay, welcome back, everybody. I'm just going to line up the next speaker before we get started. So it'll be Professor Zander Meyerberg, who will be talking about large-scale sequencing and genomics, as well as enhancing growth, resilience, and sustainability. So there's Zander there. I see he's appeared. So welcome, Zander. I'm sure, I think you're on mute, can't hear you at the moment.
Yes, I'm going to just load my presentation, just a second.
All right, so you can kick off when you're ready.
Good. Oops. Can everybody see my presentation?
Yep, now we can see it, no problem.
Very good. Good, thank you very much. So I'm Zander Meyerberg. After watching the FSA video 10 times in the break, I have to say I am a South African forester, but a new breed of foresters that will be looking at forestry through the lens of their genome. So it also happens to be the highest resolution that we can achieve in managing trees, and that is understanding the full diversity of their genome. So today I'll talk to you about a technology tipping point, which I think is going to allow us to revolutionize the way that we can do breeding by understanding their genome diversity and enhancing growth, resilience, and sustainability. So this work is done in the Forest Molecular Genetics program at the University of Pretoria in FAVI. And I'll point out some of my co-investigators and co-authors for this talk. The FNG program is now a 20-year-old industry, government, and academia triple helix partnership. So it's a very exciting venue or venture. And we have, over the past 20 years, really worked hard on developing new genomic technologies, sequencing the first eucalyptus genome in the world, and then implementing that technology in industry. I think there's more than 100 people between the FNG group at the University of Pretoria and all of our industry partners and breeders involved. There's a group of more than 100 people that are building a community of practice around the molecular genetics of the trees. And maybe also an invitation to anybody who wants to come and celebrate with us on the 29th of November. We have our annual research symposium. So if you've not been invited, you're welcome to send me an email and we'll send you an invitation, and then we'll have a party afterwards to celebrate our 20th year. So what do? We work with our industry partners and of course the students and staff in the program to unlock genome diversity. So as already mentioned, the big milestone was the sequencing of the Eucalyptus grandis genome. It was published in 2014, but we actually already had access to it around about 2012. We had the first version. So that allowed us to go back and look at genome diversity in forestry breeding trials and working with our industry partners and do forward genetics in the sense that we can identify DNA variants in the genome that could be used to identify the trees and also to move into molecular breeding. But also it will allow us to, it has allowed us to do reverse genetics, to start looking at the genes and then asking, what happens if a gene is edited, or also looking for natural variation in those genes. So this is mainly an information platform because we have access to the full blueprint of the tree, and we can now, of course, do it for hundreds of trees or thousands of trees. And so over the time, since 2008, we have analyzed the genomes of over 85,000 trees. So for most of those, we just have a DNA fingerprint. So it's essentially a diagnostic service. We can identify the trees, we can identify the parents and reconstruct pedigrees. But lately, we also have genome-wide profiles for trees. And so a lot of this is now built on some new technologies that allow us to do this in high throughput. We can do 800 trees in a day here. So this is the precision tree breeding platform that you've already heard about. And also recently, the Technology Innovation Agency provided some funding, R500,000 a year, to support small grower communities and the nurseries that provide the material for them, And standing here, we're standing here at a clone that is now for the first time planted by the small grower. And in fact, it's a black wattle genotype, of which we've now also sequenced the first genome. So it'll be the first black wattle genome. What I want to talk about mainly today is this work on understanding genomes on the landscape. So this is part of a new field called landscape genomics. It combines our ability to do high throughput genomics on tree breeding trials. And normally it's done in the natural range of a species. We've done some of that, which I will show you today. But in our case, I think we have a focus on the more applied landscape genomics, which is to come alongside all of these tree breeding trials that are already out in the landscape and identify regions in the genome that might be associated with adaptation to those sites. And of course, also thinking in the context of future changes in the environment and also matching genotype and environment. So what are the genomic landscape genomic aims? It is firstly to detect adaptive genetic variation in the natural range of the species, then elucidate which environmental factors a particular species or population or provenance has adapted to, then predict the impact of future changes over time or over space if you move species around or provenances around. This is typically what we've done over the past 100 years. We've brought eucalyptus provenances, species and provenances into the country, tested them here, and then to develop strategies to breed for desirable genetic variation based on this information. So those are the goals we're going after. So as a first step into this is a new field for us. We've never done this before. This is now before 2017. So we chose Eucalyptus grandis for the reason that it is the species that has the most advanced breeding populations. We could, in fact, not even get our hands on first-generation material in South Africa anymore. And we had to import seeds from Australia to re-establish grandis, and this time to re-establish it with the full diversity, every single provenance we could get our hands on. And Maya O'Neill, who's here shown at the bottom left, she was the PhD student who did this work. She later finished a postdoc, and now she's appointed by Mondi as a genomic specialist. So you can see that there's investment in people to apply this information in industry. So landscape genomics, first step was to understand the population genomics of Eucalyptus grandis. So the natural range is here on the east coast of Australia. And of course, the other important part is then the environment. And Australia has a very rich resource of information for all of the provenances. We were able to draw upon that and look for association between genotype and environment. I'll show you just in a couple of slides some outcomes from that. And then the last step will be to then establish common gardens. So take all of the seed that we imported from Australia and establish common gardens, which in fact has now happened in South Africa. Those are already growing, and those allow us to test hypotheses from what we see in the wild, but also having those trials that allows us to start looking at genotype by phenotype associations. So that essentially is market trait associations, and of course that will lead eventually into genomic breeding. So just very quickly, this is what we did. We had 33 provenances and 193 families from those provenances. They're from the entire natural range. You can see there the bubble graph. And Mondi was so kind to help us to establish a small number of individuals from each family into a conservation park, which is near Greytown in the Natal Midlands. So it's an amazing place to visit because you can see there the full diversity of the species. So, and then I should just mention is that Maya then also used this technology, the SNP chip technology. So it's looking at essentially 25,000 places in the genome and looking for changes between all of these trees to understand the structure, the genetic structure throughout the genome. This is what the trees look like now. They are now 4 or 5 years old, and as I said, it's amazing to walk through and see the diversity in leaf shape and stem form, color, bark color, thickness. So we've already sampled from these trees, and we are already beginning to analyze genetic materials from them. They're also flowering now, which in fact is a fantastic opportunity to recreate the process of what it would have been in the early days of breeding, to take these forward into the F1 generation, to reestablish a new breeding program with the full diversity of the species. Something that emerged very quickly from the analysis was that if you compare these provenances in the north and those in the south, there's sort of two subgroups in the south. They are less differentiated than the two groups are from these provenances in the middle here, the Mackay provenances. This is an area that has undergone aridification over the past 5,000 years or so. And so we suspected immediately that there might be some integration, so hybridization maybe with a more drought-tolerant species or heat-tolerant species, and then, which provides an adaptive benefit to those local provenances. And Maya did a fantastic job of then using those 25,000 markers. So if you take let me explain quickly what's here. These are the 11 chromosomes of eucalyptus horizontally. And you've got the 25,000 markers. You can't see them because the resolution is not high enough there. But if you essentially follow a moving window throughout the genome and you look at groups of markers, and because we have the reference sets for the species, we know the genomic profile of a pure Eucalyptus grandis tree, and we also have a bunch of others, Eucalyptus urophylla, and also some of the Madenaria species, nitens, globulus, and so forth. We are able to then match the genome. So we can see a pure Eucalyptus grandis is supposed to be gray in this particular analysis. So we're looking at local ancestry, meaning we're asking for each part of the genome, what is the ancestry? And so if it's a pure Eucalyptus grandis, the entire genome would be here at 0. It would be grandis. And in fact, so what you see here is one of the provenances, Finch Hatton Gorge. From these provenances here, you can see throughout the genome, we see integration from some other source. So we don't know exactly what it is. It is also in the same section as Eucalyptus grandis, so it's related. But we also see, in some cases, we see possibly integration from more distantly related Madenaria species, some of the cold tolerance. So we haven't identified the species, but we can determine conclusively that there's hybridization and integration happening in that area. So which is very interesting. And we've subsequently been able to use the same visualization and technology that Maya established to look at grandis in our own breeding populations here in South Africa. And we can see something very similar happening in Zululand, as you would expect, where you have disease pressure. We see integration from Eucalyptus urophylla. And that would happen inadvertently as breeders select the best trees growing in those environments. So the other aspect, of course, the second one is the environmental association analysis. And just very briefly, I can say that we've been able to use all of the environmental factors you can get. So rainfall, soil, elevation, distance from the coast, latitude, and then look for associations between those factors and the genotypes of the trees that are in these regions. And so we can see clear, strong genetic signal. But with 25,000 markers and there's 36,000 genes in the genome, it's not possible to assign these necessarily to individual genes. And so this is the whole motivation to now sequence genomes of not just the trees that Maya sampled, but a much bigger set from these conservation parks. So the information is published in a paper in molecular ecology. So if you want to see more about the natural range of Eucalyptus grandis, and then Maya also did an analysis of our breeding populations in South Africa. So this is basically looking at artificial selection over a period of 100 years. So we consider that early domestication of the wood fiber crop, and very interesting findings that essentially we've already shifted the genetic profile of grandis significantly here in South Africa. So the last step is a common gardens, and just one slide to show that. So SAPI and Mondi and also CAMCOR is coordinating the wider international effort. Helped us to put together these, to establish the common gardens, so they kindly are maintaining those. So you can see here in Zululand, SAPI has established the full set, which is 189 families, but there's a core set from CAMCOR, for which we had a much bigger seed lots. that is established across all 4 of these sites. So we have a very nice open air laboratory. Essentially, this is from the SAPI, the first trial that was planted in Zululand. So you can see here the amazing diversity of Eucalyptus grandis. Very interesting around it. These clonal plantations. It's good to go in there and have a look. We've collected leaf samples from all the trees, put it through our robotic systems, extracted the DNA, and the sequencing of these trees is ongoing right now in the USA at the Joint Genome Institute, and we will soon have a deluge of data coming in. SAPI and Mondi are also helping with the measurements, so we're testing different measurement technologies. So this is airborne LiDAR, so we can also get a good idea of variation in height of the trees and some idea also of canopy structure. So there's a lot of opportunity to look at leaf level, canopy, and also under canopy. As these trees grow up, the clear stems will be available. And so I've already talked to Dave True at Stellenbosch University. We're planning to look at stem form diversity. This was some of the first trees that we looked at. These were at about, I think it was 9 or 11 months. So they're really exceptional trees in there, and also very interesting if you look at the variation in leaf shape and size. I suspect that some of these might be natural hybrids as well. So there's an open invitation to anybody in the country who's interested to join us. We recently had a forum, a research forum meeting here at University of Pretoria, but anybody who's not involved is welcome to. If you want to look at these trees and leverage the genomic information that will be available, you're welcome to contact us for that. We're looking for collaborators that can help us to characterize these trees. Just quickly how we are going to sequence the genome. So this is part of a wider process, a bigger effort internationally called the 10,000 Eucalypt Genome Initiative. It's based on an arboretum in the south of Australia where you can see here all over Australia where being collected. This is a citizen scientist, Dean Nicole, who did that. And so of the 988 species of eucalypts that's available, so this covers Angophora, Corymbia, and Eucalyptus. There's 953 species available there. So they are planted in 3 tree row plots. And I think there's 2 replicates of each block. So there's 6 trees of each species, and all 6, so there's about 6,000 trees, and the group, our collaborators in Australia at Australian National University have already collected leaf samples from all 6,000 trees. And then we have another collaborator at University of Connecticut in the USA, and she's a computational biologist. So we want to sequence the genomes of all these trees. We need some serious informatics, computational resources. The University of Connecticut is one of the best in the world in that. So we put forward this proposal to the Joint Genome Institute in the US, and it was funded. And as I said, the work is ongoing. There's no money flowing to us, but they're doing the work internally for us. And my estimation is probably somewhere between 15 and 20 million rands worth of investment in eucalypt genomics. So a very quick graphical overview of what is being done. So there's the genomes of the 950 species. 10 of those will be designated as references, and that just means they throw the kitchen sink at it. Every single possible omics is being done. So we're looking at genes being expressed in those trees. We're looking at the structural variation in those genomes. So that is a way for us to align the genomes and then understand not just what are the individual sequence variants, but also the structural variants. We now know that if you look within a species and between species, that there are many places where there are even whole genes that are present and absent, and we suspect that many of those would be present and absent at provenance level. So maybe there's adaptive forces at play. And so we've been blind to this up to now. And so this is also a source of future potential molecular breeding of understanding this kind of, which is what I'll call pan-genome variation in these genomes. The main effort, what I will show you, is sequencing the 2,000 Eucalyptus grandis tree from about 170 families we have here in the country in our common gardens. There's a parallel effort in Australia to look at Eucalyptus melodora, which is a model for restoration forestry there. We'll go through a process of, once we've sequenced the genomes, to collapse them into blocks. When we look in any population, you can actually find lots of variants that are closely related, that are co-inherited. So you can think of this as the Lego block model of the genome. So just a way to reduce the amount of information and also give us anchor points to select in molecular breeding. So we can get an idea of the broad scale genomic composition of these 2,000 eucalyptus grandis trees. And that gives us a map of the so-called hap map. So these variants are called haplotypes. So a block of DNA that's co-inherited is a haplotype, and that gives us a hap map. And that will give us the resolution to go back and look for the associations at the environmental level. So that is the landscape genomics, and all of this information will go into Steve Forain work on this data plasm, which will contain all of the fingerprints of the trees. We're also working with the Innovation Africa and the Information Hub, where we will be busy developing a new app. So it's a tree information management and molecular breeding resource. And so that will be an app that we are making available to breeders to be able to access this information. And then lastly, I just want to mention that we are working on a sector innovation fund proposal. We're planning to sequence about 100 genomes of Eucalyptus grandis that represents the founder material. So some of the oldest trees, first generation, second generation, we can get our hands on. It will cover hopefully both solid and pulpwood populations. And then the idea is to track that diversity from the natural range, see what breeders have been selecting for, and then working with companies like Hans Marinsky, Mondi, Sappi, to then look at their breeding populations and to trace all of that diversity through to their breeding populations and seeing what breeders have been selecting for. Of course, what is important here is what is missing. So what diversity has not been integrated yet into the country. And we now know, like those Mackay provenances, some of those may have important adaptive variation for future climate change. And so this is all giving us a full framework. And it's a new paradigm for molecular breeding. This is what the crop breeding community has already been embarking on, and we can see some powerful outcomes from that. There are some service companies in the US, so we can bring the cost down from that point forward to track these blocks, these haplotype blocks throughout our genome. So just in broad scale, the deliverables here is to gain a understanding of woody biomass formation, so the genetic variation underlying that, of course, to find the genes and DNA markers that can be used for molecular breeding. The second main outcome is understanding genotype by environment interactions, and again, looking at the genes and possible genetic variation that can be infused into South African breeding populations. And then lastly, the practical biotechnology tools. So we'll have the species, founder, and breeding population haplotype maps, and then having high throughput affordable genome sequencing technologies that can be used for routine molecular breeding of these trees. And then really thinking about deploying genome-assisted breeding for biomass and adaptive traits in these species. So just to thank the group of students and postdocs working with me and staff here at the University of Pretoria and in FABI. And finally, again, that invitation out to everybody that's interested to participate in this effort. We also have a large international group of people that are interested. So it might be worthwhile to engage with us and be part of this exciting new development. Thank you.
Thanks, Ander. Yeah, that was great. I think we do have one question, and yeah, it's one of those burning questions. It's from JC Brandt. It's how far are we with overcoming the resistance to genetically modified trees, particularly from a forestry certification perspective / bodies?
Good, yeah, that's of course a question that is often asked. So FSC has embarked on an effort to try and understand how that could be used in the future. So there is currently a study undergoing but we don't think that there's going to be acceptance pretty soon in Europe, where most of our wood products go. And so at this point, I don't foresee that within the next 10 years, we're going to see any GM tree being commercialized. You know, we also have realized by sequencing these genomes that, in fact, if you sequence enough genomes, you can find for any particular gene you're interested in a variant that might either increase this expression or even knock out its expression. So there are other ways to engineer the genomes of trees. Is if we can sequence these genomes, understand their diversity, and then cross the right trees, we can in fact achieve much of what could be achieved, and maybe much more efficiently than having to do genetic manipulation of these trees. It's quite hard to do genetic transformation of eucalyptus trees. They're sort of some of the most difficult organisms to genetically transform because they have such potent defenses. They are actually extremely robust plants, and trying to infect them with a bacterium and then transfer DNA into their genomes is really challenging.
Okay, thanks, Zander. Thanks for that. Okay, so I think there's opportunities to put some more questions to Zander. Just in the interest of time, we're going to move on to Dr. Jacob Kraus from SAPI, who's going to talk to us about resource sustainability. So thanks very much, Zander. And Jacob, I think you're next up.
Good afternoon. Just confirm that you can hear and see my screen.
We can, Jacob. Everything is good.
Thank you very much. So I just want to, at the start, acknowledge my co-author and colleague, Dr. Stephen Dovey, and I'll be talking about resource sustainability. Sustainability is quite a broad concept, and most of my talk will focus on the narrow sense of sustainability. However, we have to look at the overview first, and due to exponential population growth, there's increase in industrial and technological growth, which is associated also with increased energy use. This also requires increased farming, and as a result, we see greater greenhouse gas emissions, as well as deforestation. The bottom line is our planet is reaching a breaking point. In the graph here at the bottom, you can see the increase in emissions from the agriculture and forestry sector for the past 2 decades, and it's summarized by decade. And in terms of deforestation, we've seen most of the deforestation was associated with shifting agriculture, and further emission increases as a result of additional energy use within the supply chain. The broad definition of sustainability is the responsibility to conserve natural resources and to protect global ecosystems to support health and well-being now and into the future. And the natural resources are really a limitless list there, but I will focus today on water, soil, and plants in my talk. It's also important to realize that sustainability has 3 pillars. Sometimes people represent this also as 3 circles that overlap because it's not individual pillars as such. The social, economic, and environmental part. And this can also be referred to as people, prosperity, and planet. The society is putting more pressure on companies to disclose their sustainability impacts, and it's becoming a requirement to trade. There has been an evolution of disclosure standards over many years, and hopefully this will converge into more standardized systems with the International Sustainability Standards Board that was established 2022, and it was announced by COP26 last year. We've seen references to some of these, UN Sustainability Development Goals, SAPI report emissions through CDP, and we're also busy reporting through the Task Force on Climate-Related Financial Disclosures. Luckily, most of these systems are based on a similar concept, and just to focus shortly on what sustainability information should be disclosed. They have various levels of disclosure, and then you can also see in this graph taken from the JSE disclosure guidance, the 3 parts that I've already referred to. And at the highest level, it's related to the board's oversight of sustainability-related impacts and risks, as well as opportunities, the company strategy. Then there's a level of risk management where you have to quantify the risks and opportunities and show how that's integrated into the organization's management process. And finally, the development of metrics, targets, and performance. And you have to report against these metrics and targets. Just to focus a little bit more on the environmental side, I've been doing some work on the climate change, working on carbon footprints, as well as looking at potential impacts of future climate changes. But there are many other sustainability indicators that still need to be developed, for example, on the biodiversity and land use and supply chain. The first that we identified when we started to develop these metrics and to report against the metrics was the lack of data. And you have to start with the future climatic predictions. So between Mondi, SAPI, and Forestry South Africa, we partnered with the Global Change Institute who supplied us with climatic data from 6 different global climate models, but downscaled specifically for South Africa. And this was summarized and analyzed by Stephen Dovey in SAPI. And the animation that you see here is the change in the silvicultural zones that we can expect from 2000 to 2100. You will see as it scrolls through that the cool warm areas disappear almost entirely, and most of the forestry areas becomes dominated by warm temperate subtropical as well as dry tropical areas in the future. Analysis of this work also showed us that we should not only focus on the mean annual temperature changes or mean annual precipitation changes, but look at interannual changes. In this graph, I'm showing the example of Elandshoogte Block A, comparing 2000 to 2004 predictions. The bars indicate rainfall and the lines the temperature. If we just focus on the rainfall first, it shows the months from January to December, and the black bars is the rain in 2000, with the yellow bars the rain predicted for 2040 decade. And you can see there's a prediction of lower rainfall from February till October, with higher rainfall in November and December. Then, as well as decrease in rainfall in October, there's a significant increase in maximum temperature predicted, and this might have severe implications for fire risk as well as stress on the trees that has now to cope with a longer dry period as well as increased temperatures at the end of the dry period. We've used this information to determine the economic impact of these physical climate risks on our forest resources. And in order of magnitude, I've listed the top 4, where we've identified increases in fire risk classes as the highest risk. That's followed by multi-year droughts that will decrease timber production, a decrease in tree growth due to a chronic increase in temperature, and increased losses due to pests and diseases. Other risks that we've identified but not yet quantified are increases in extreme events, site degradation, constraints in supply of water, raw materials, energy, as well as decreases in human productivity. Also, part of the sustainability reporting, you have to address mitigation and adaptation measures. Mitigation refers to actions that reduce greenhouse gas emissions, that will reduce the size of the climate change. Adaptation refers to actions that enable you to adjust to the increase in temperature. I have to say upfront that climate change can result in degradation despite adaptation measures, where that change exceeds the limits of adaptation. So it's important not to only rely on adaptation, but also address mitigation. What can we do? We can preserve and restore our natural ecosystems. We have to focus on sustainable land management, and there it's important to enhance soil carbon. We can retain our crop residue by mulching and prevent soil erosion. Crop management is important, and we've heard this morning from Arno that we must breed and use varieties that heat, drought, and pest and disease tolerant. We have to focus on weed control as well as fertilization. Another aspect that we heard from Bernard this morning is measurement, monitoring, and early warning systems need to be developed and expanded on. Fuel load management will become more critical, as well as improved fire prevention and control. Then we have to reduce our greenhouse gas emissions from our operations, and I've listed here harvesting and transport, as these two components have quite a large fossil fuel footprint at this stage. What can we do about this is to substitute fossil products by using renewable bioenergy products. To elaborate on this, I want to refer to a study that was done by Dr. Peter Holmgren for the Swedish Forest Industries Federation. And he demonstrated that the substitution benefits of plantations or even natural forests are much greater than the storage benefit of the forest. He compared two scenarios. In the first scenario, whereas a sustainably managed working forest that produce renewable harvested wood products that replace fossil fuel emissions, that's used in a circular forest bioeconomy, compared to the counterfactual scenario where the forest is preserved and used to store the carbon, and fossil fuel emissions continue unabated. And he demonstrated that there's a large greenhouse gas benefit and a more removal of carbon in the atmosphere if you have a circular forest bioeconomy. However, this will mean that there's more pressure to utilize more biomass from our forest. And from historic work, we've seen that once you start removing the residue as well as the forest floor, there is a decrease in timber production. And I want to use two examples. So one was a research trial series established by Dr. Andrew Morris at Lesotho, and it was analyzed by Lindani Magambela. And the bottom line here is where the tree growth volume production associated with areas where the slash and the forest floor was removed, no fertilizer was applied, compared to areas where the slash was retained, and a further increase in production when fertilizer was applied and the slash was retained. We've also seen similar results from Eucalyptus grandis. This work was done by Professor Ben de Tooy for the C4 trial series. At the bottom, you have slash removed versus the two top lines where slash was retained or where slash was burned. So what have we done to address these things? We've started with nutrient depletion studies in 2012 in association with the ICFR. And this work was funded by Moni and Sati from the start. And here the aim is to develop tools and indicators to monitor and report change in the soil. We are using high density planting of 10,000 stems per hectare and annual removal of the biomass to deplete the nutrients as fast as possible on certain plots. And throughout this process, we measure both the tree response as well as the soil response to understand what's happening. And this work has also shown us that if you remove all the biomass, then there is a decrease in tree growth. But it has shown us that you are still able to grow trees on these sites despite the excessive nutrient removal, yet at a lower production rate. But the system didn't completely collapse with our maximum removal. And we also realized that this is not a true reflection of what is happening when you harvest trees, because with a normal harvesting of mature trees, you remove different proportions of nutrients. So we started to establish long-term soil monitoring plots in 2018, again through the ICFR. The aim of these plots are to assess soil changes across rotations, and this is essential to monitor attributes that may change slowly or that are cumulative over time. And these plots are linked to our PSP network. I would like to invite any of the other industry members to join this network, even if you only establish one plot per year. Our aim is to have at least 100 plots established within the first 10 years of this project. Within SAPI, we've also realized that we have to address the risks associated with site degradation. And as part of a multidisciplinary team, we have developed a site sensitivity risk map. This information shows us where we can expect high and extremely high risk areas. And the foresters must then identify the best management practices to limit the negative impacts associated with a specific operation that they plan on that site. To talk a bit more about mitigation and adaptation methods, I've identified harvest residue management as one of the key factors that we should focus on. And I see a large opportunity for mulching of harvest residue. It has multiple benefits: protect the soil from erosion and compaction. It conserves soil moisture because it increases percolation, retention of the moisture. It reduces weed growth, moderates soil temperature, increases nutrition. It increases tree survival and growth. Just maybe a side note here is that the harvest residue should not be mixed into the soil, because that can result in a nutrient lockup. The best is to leave the mulch and not to mix it into the soil. And there's also opportunity to reduce greenhouse gas emissions. I've calculated that avoided burning emissions can be as much as 3.8 tons carbon dioxide equivalent per hectare. And then there's additional carbon dioxide removal due to faster growth. To substantiate these claims that I make, I want to refer to work that was done by Tabachu Machaka for his master's degree. And he monitored soil moisture in mulched and burnt areas. The green line that you see in this graph indicates the daily fluctuations of soil temperature on mulched plots compared to the red line, the soil temperature in burnt plots. And the blue line is the air temperature. Stephen Dovey has also monitored soil water on burnt areas versus mulched areas. And you can see that almost for the entire first year, the trees on the mulched plot had much higher soil water contents available to increase tree growth compared to where it was burnt. Future work should perhaps focus more on rainfall reduction, like the Brazilians have done, to give us a better understanding of the physiology of drought adaptation. And here we should not only focus on drought tolerance, but also on the recovery part when rainfall increases again. The final risk I want to highlight today is related to the application of sustainability indices and use of data to calculate these indices that are based on global models and that are not suitable for short rotation industrial plantations in South Africa. An example that I want to use is this Global Forest Watch carbon flux data set that is available on the internet. And in this case, South African industrial plantations are portrayed as a large emitter of greenhouse gas emissions. In this data set, they very accurately report tree cover loss as well as emissions on an annual basis, but tree cover gain was only assessed at the 2001 to 2012 period, and this has recently been changed and updated, but now the tree cover gain period looks between 2000 and 2020, and there's not an annual tree cover gain assessment, which means in this particular example, they could miss up to 2 eucalyptus crop re-establishment activities, but report the emissions from 2 or more crops. And in this case, to quote Giovanni, we need locally relevant and internationally accepted data sets that are published in the public domain for people to use in South Africa and abroad. To conclude, climate change brings opportunities as well as risks for the forest industry. The future profitability will depend on the ability of the industry to predict, detect, and rapidly respond to change. Sustainability reporting requirements will increase in future, and this will require knowledge of what to measure, the development of the diagnostic tools and indicators, the regular measurement of these, and then the reporting of the progress towards achieving the targets that you've set. Thank you very much.
Thanks, Jaco. Yeah, there's good talk. I know you squeezed in a lot there, but yeah, well done. There's a comment from Ilaria, and she's saying that the challenge is to balance the interventions sometimes clashing. For example, fertilizer applications to prevent site degradation. This increases emissions, links to fertilizer production, transport, etc. Fuel load, fire preventions versus retaining the residue, and the reduced soil nutrition losses to reduce emissions. So what Ilaria is saying, it's a very complex puzzle, but crucial to the industry's long-term sustainability. So that's just a statement from her, which is really what you've highlighted. But then there's a question here from Dave Dobson. So he says, would you comment on the use of woody biomass tops/branches and leaving behind the bark and leaves? How do we manage what you keep and what you take off?
Yeah, Dave, we know that the foliage in particular and the small branches have very high nutrient content. So it's preferable to leave these components behind and focus more on the woody biomass components. And there is quite a bit of harvest residue left behind, consisting of non-utilizable species. And if you limit your biomass extraction to these woody components, you will have minimal impact on the nutrient content of the site. And there are further options of returning the ash after you've used the biomass for bioenergy. Thank you.
All right, there is one last question from Jacques, but I'm going to have to ask, because it's quite a long little paragraph there. So I'm going to ask Jacob to answer Jacques in this Q&A while we move on to the next speaker, which is Tandenda and Mapeto, and she's going to talk to us about the role of youth in sustainability, and currently is working as a lecturer at Sarsveld or Nelson Mandela University. So Tandenda, I hope you're ready.
Good day, everyone. My name is Tatenda. I'm a forest management lecturer in the Forestry and Wood Technology Department at the Nelson Mandela University. I'm honored to be presenting at the 2022 FSA SIFE Research Symposium. I'm going to talk about the importance of youth, young researchers, for sustaining research. I will lean more on why it is important for research to be inclusive of youth and how we can collaborate with young people. I will also showcase some exceptional young people in research in their work. If we look at the global context of the current development agenda, the Sustainable Development Goals, they are all connected. This means they must be underpinned by collaborative, interdisciplinary, and transdisciplinary scientific research. That includes intergenerational equity. Forestry is a long-term industry. It is an industry steeped in both slow and fast research variables. To a large extent, forestry research is about the development of sustainability solutions in the middle of complex situations. This means our research initiatives need to incorporate diverse knowledge systems, diverse worldviews, by using a broad range of stakeholders, disciplines, methods, and tools. Intergenerational partnerships are therefore critical. Involving the young people is critical in effective decision-making and knowledge production. Moreover, younger generations are the most affected by the realities of global change. And younger people also bring important intergenerational perspectives to the development of sustainability solutions. A key problem, however, is that our younger people, I mean those under 40 years of age, constitute 65% of the global population. They are insufficiently integrated into decision-making or science policy interfaces. Looking at two graphs, one at the top as well as one at the bottom, labeled B and C, you can see just the general average age of heads of states by continent compared to the general average age of the population. For Africa, the general age is 65 for a head of state, and the general population age is 18. There's a clear disconnect between young people and those who are making decisions that will affect them now and in the future. If we look at the science interface, this is a graphic that was also developed by Lim et al. 2014, which shows the general age or career age of authors that contribute to the IPCC report, Interpanel on Climate Change. This shows that the young researchers, the early career researchers, contribute a very small percentage to the overall number of authors that actually contributed to this report. Again, a disconnect between the representations of young researchers in the bigger scheme of scientific research. This is the global context. So what is the role of youth? The role of youth, as I was researching, came to 4 points. To take up leadership positions, to steward research legacy and also changes as they happen, to stimulate change within the research landscape, and to be protagonists for solving crises. Youth are embedded within our research communities. They must be given the platform to lead. They must have influence on current strategic decisions. This is because these decisions affect them now, and they will also inherit future potential consequences, either as professionals or human beings. How do we then do this? We must foster collaboration between young people. This allows them to bring intergenerational perspectives, skills, and insights. And if we can think, what is the unique thing that young people bring to the research landscape? just 1 or 2 points maybe. Generally, younger researchers are recently trained. They therefore bring practical experience of the latest methods and developments. Secondly, with the call to transdisciplinarity and interdisciplinarity that we have in our current world, young researchers are, I would say, the first generation that have had some form of grounding or education in transdisciplinarity and interdisciplinarity. This gives them an edge over being comfortable in working on complex research problems that we currently face. Thirdly, young people have got informal networks, but often these informal networks are not tapped into for research purposes. We must leverage on young people's networks for research purposes. And lastly, for us to be able to have young people realize their roles, a big part of it is being able to tolerate a higher level of innovative ideas and trying to be bigger risk takers than we often are. So there are many ways that we can actually look at different frameworks to collaborate with young people. And this is just an example of a conceptual model that was presented by Jorgensen and others in 2019 on how can we look at the collaboration landscape with young people. It just illustrates how youth collaborations develop over time in these research initiatives. So in this case, young researchers or youth are being called early career researchers, ECRs, and it is showing that although we've got different collaboration models, so invitation only as a collaboration model where one is invited, or collaboration through early career research bodies, or collaboration through open recruitment of young people, or involving young people in strategic decision making. These are not really mutually exclusive. Usually, although they developed over time, sometimes you can note that as an industry or as a nation, we could be still working with an invitation-only basis. So, for example, an invitation-only would be being invited to be part of a consortium for a sector innovation fund proposal. That would be at the very basics of how we collaborate, inviting them into your spaces. But we can move on further and start looking at how can we actually have research initiatives that allow young researchers to coordinate in committees or in forums. This ensures a broader impact of youth on research. This ensures that their role is realized and that their contributions can be considered at an overarching level by mandating participation in strategic decision-making bodies. So once you have some form of organization, some form of coordination, you automatically open a pathway to collaborate with young people, not as individuals, but also as a group that is a key stakeholder in how decisions are made from a strategic perspective. It's difficult to do that when you only collaborate at the individual level. Finally, the last stage would be once you've built on these communities, you are now collaborating by using existing networks between the communities. So you leverage the institutional capacities of the young researcher communities. It has been shown that research initiatives that collaborate with institutions of young researchers are actually the ones that are able to then move to what we call bidirectional collaboration. So it moves from this level where it's just limited and unidirectional individualistic collaboration to a more perspective where the younger researchers are actually contributing to shaping research, to the organization of the research, and they are now involved in substantial decision making. So, like I said, they are not mutually exclusive, but it is important to note the different ways in which we can do this and maybe ask ourselves, where are we as an industry in terms of how we invite young researchers into the forestry research landscape? To engage then the youth, it will be important to always be clear that young researchers are crucial in the identification of, in the engagement with obstacles, opportunities, and in the development of innovative solutions. These innovative solutions are often to complex problems or problems that are often interconnected, and potential practices that we can put in mind on how we engage with young people could be bringing them on when we scan the horizon for scenario building, for future casting, for dialogue processes, for research questions, bringing them on to contribute to research agendas. It is also important to actually bring the young people in planning for particular research projects, in consulting, in mapping different research initiatives. This fostering of collaborations and empowering of young people allows the youth to lead in research and to realize their role of stimulating change, stewarding change, innovating, and sustaining and being a part of the research landscapes. One of the key things that always comes up when the topic of youth inclusion is brought forward is the question, but where are the young people? It's almost like when we speak of young people, we speak of a vague demographic in research. But I wanted to take an opportunity to say there are a lot of active young people in the South African forestry research community. And I reached out to some of them, and I got responses from some of them. It was a bit late in my reaching out, but they are exceptional people. And with permission, I'm just going to share with you what they're busy with, their projects, etc. The first one is Willie Hector. Willie is busy with his PhD and is looking at the various causes of mortality during the re-establishment phase in eucalypt plantations. He's also looking at what are the mitigation measures for these various degrees of mortality. When asked, how did you land into this research pathway? Willie says he's always been passionate about silviculture. He wanted to pursue a career in the field of silviculture, and especially in the field of survival. Some highlights would be meeting new people, seeing new places, and actually Uli has always wanted to get a PhD since he was in school. The next young person is Gulu Sikau. He's currently pursuing his master's in forestry and is looking at what is the influence of site characteristics on tree growth and wood properties on two of the most pine species in the Southern Cape forestry region. When asked, how did you end up here? Relation that comes with research. And a highlight is always being surrounded by academic staff who are actively involved in your academic development. Exciting. The next young person is Nonku Ndinga. She's a personal friend of mine. She is looking at data-driven decision-making using various data collection and analysis techniques, such as time studies. She is also one of the few economics experts in the country. How did she get here? How did she hop onto a research-oriented career? An analytical mind, curious mind that actually was sparked when she was doing her forestry training, and she ended up at the operations research division, which was a perfect fit, but she didn't know she needed that time. Sometimes it takes exposure and mentorship for somebody to actually realize, I absolutely want to follow a research career. A highlight has been that she developed or was part of a project that developed or achieved 80% reduction in slip, trip, and fall recordable incidents because of ergonomics, and obviously completing a certificate in ergonomics as well. The other young person is Nonte Ramotswana. She's currently working on a proposal for a PhD in forest science, looking at what factors contribute to small and medium-scale enterprises, forestry contractors' success and failure in South Africa. How she hopped onto the research path was when she worked with Professor Kurt Geldenhuys, and she also worked within the silviculture area, and that sparked her love for a research journey. A highlight has been being able to start her own company, to run an online newsletter on silviculture technologies, and this always gives her an opportunity to work with diverse researchers, foresters, and exposure to various challenges, stakeholders in forestry. The other young person is Richard Ferreira. He's working at how do we apply smart sensors in commercial forestry to look at the relationship between the tree physiological functions and water. How he got onto this path is he's always been fortunate to work with supervisors that were supportive of the applications of remote sensing in forestry as a tool for risk management and decision making. Some highlights for Richard have been discovering and working with new technologies and just being in awe of how far we've come. Ladies and gentlemen, just looking at these young people's work gives you an idea of how passionate and how excited they are. And this is less than 10% for the people working in forestry research in South Africa, and they are young people. This means, to conclude, as young people, we must be cognizant of the fact that we are going to be requiring transdisciplinarity and multidisciplinarity to solve real-life problems. It is important that we continue to think about how do we collaborate and empower young researchers from both academic and practitioner backgrounds, because that's essential for sustaining forestry research. And there are different pathways on what that collaboration looks like. The good thing is we already have an active and exceptional youth cohort in the South African forestry industry. Like I said, the few that I've presented are just a tip of the many that are excited and passionate to be carrying out research in this industry. And that leads me to end this presentation on maybe we need to form a young early career researchers forum for the South African forestry researchers industry. It's just a thought I had as I was finishing to prepare for this presentation. Thank you very much for listening to me. I really appreciate it.
Thanks, Tatenda. That was great. It was a nice personal touch at the end there. I really appreciate that. We didn't get any questions at the moment, but I do have a question about the difference between the two models. If we look at traditionally, a lot of students will go from honors to masters to PhD within a department or sister department, and then you get the odd few people that leave after their BSc and go into industry just for a year or two. They pick up some experience. So there's quite a few academics that are sitting around the table. What is the model that most of you prefer? The person that's gone out and learned a little bit first and then come back, or pushing them through the pipeline if you can get funding for them? Which one is a better choice or outcome?
Thanks, Wayne. I think there's definitely going to be two types of researchers in our industry. You get the applied type of research where they're very much focused on what they produce is going into management recommendations as quickly as possible. So from that perspective, you want somebody who's got a little bit of traction in the industry and understands what their contribution is going to be from a management perspective. And they also are able to frame their questions easier, if I may say it that way. But you also get some students who really want to go on and become researchers, and they can literally move from a BSc, although in genetics, for example, and move all the way to a PhD and still be able to contribute dramatically once they walk out of the terminal degree, such as a PhD. So I don't think there's one better or the other. It just depends on the type of research that you're going to do. If it's I don't want to say pure science, but if it's almost there's a word for it, I just forgot it now. It's a science that not linked to management in the short term. There's literally no reason why you can push this person. But if it's an applied perspective, sometimes industry experience helps. In our university, we often do applied work, and a lot of the students have focused, have showed now, or practitioners are applied researchers, and they do have some bit of traction in the industry, which is helpful. We need both to make research useful, as we have seen from this morning's presentation.
All right, no, thanks. There's been a couple of comments in the chat there, and then also some support for the forum. It sounds like a good idea. I think a lot of young students are often a little bit falling left and right, not quite sure what they want to do, and having that little opportunity to bounce ideas off with each other often helps a lot. There was one here from Dave Everard, just quickly. What is the biggest barrier that must be removed to get more young people involved?
I think it's exposure. Some young people don't know that they can actually take up a research-oriented career, or they need research skills to do their job more efficiently. I think every person working should have an idea of how to collect data and analyze it and just make good decisions from the basics of it. So it's just the exposure of how does this research type of thinking link to how I'm going to work as a manager or either in a research-oriented career. So the more we can expose the young people, it's probably going to open it up to them wanting to be part of the research landscape.
Okay, yeah, thanks very much. Yeah, that kind of brings us to the end of today's activities. So I just want to say, Thandela, thanks for your contribution now at the end. Ended on a nice personal note, having an opportunity to see those young scientists, which is great. Then I just need to thank, firstly, all for those who stuck it out with us. It's great to see the contribution and participation. We've got, also to thank the speakers for giving up your time. Your time is precious, but we can strengthen the forest industry by the quality of the presentations as well as the depth of where people are thinking we need to go. So that's very encouraging. Also then to the hosts of this event, FSA and SIF, as well as to Katie and Aidan who helped us with in the background. Thanks very much. Also to FSA, to Michael Peter, as well as Bram de Prier from SIF, President SIF. Thank you very much for allowing this process to start. I think also what's important here is that we're going forward in developing the Science Symposium. So this was a kickoff round. It was just a first little taste of the future. I think in 2024, we're really looking for all those young students that are starting their honors degrees, MScs, halfway through their PhDs, to start thinking about what scientific papers they can actually write and present at the next symposium in 2024. And so, yeah, so we've been encouraged by the participation. We are glad to get it back on track because there's been quite a big gap. So all of a sudden, we're starting to feel a lot more comfortable. This relationship between FSA and SIF can continue, and we're really looking forward to the next one in 2024. So thank you very much for everyone's contribution, questions, and presentations, and just sitting it out with us. It was enjoyable. Thank you. So I think that's it. So you can go and work again. You can carry on with your research.
Just quickly, let's just get all the panelists to switch on their camera so we can get a group shot just before we close off.
Oh, there's Arnab is still there. You need to sit forward a bit, Arnab. Yeah. Okay, that's better.
Here we go. Nice big smile. Thank you, everyone. Wonderful morning.
Thanks.
All right.
Thanks very much, Aidan. Thanks, Katie.
Thanks very much.
We'll be in touch.
Thank you for organizing.
Thanks, everybody.
Thanks, Aidan. Thanks, Katie. Goodbye.
Cheers.